Dear all, welcome to Ankara. And we are very excited and happy to welcome you all here for our workshop called Collaborative Analysis of Flooding Events with Processing of Earth Observation Datasets, which is supported by ISPRS, also with big support of Chamber of Survey Engineers. We have a very excited program and interesting program, I must say, today. We will have lecturers from Hydropolitics Academy Association, University of Manchester, Middle of Technical University, and Istanbul University Cerrahpaşa campus. This event, as you know, organized by Akdeniz University, Hydropolitics Association, and the University of Manchester all together. And we have here, as you know, this is very multidisciplinary topic, and recent days we face really big flooding events globally, also in our country, also in Libya recently, and this is also in the near future also we face these events. And as researchers and scientists and students from different fields, we all have different methods, and what we need, we have to work together, we have to think together. And I hope this workshop will give you some insights to accelerate your research and your collaboration, especially for your future projects collaborations. And first, I will introduce our colleague Fulya Aydın Kandemir from Hydropolitics Association. Also, I also want to thank our co-PI of this event, Dr. Doğuşan Kılıç from University of Manchester, for all this organization. Also, Ms. Merve, thank you very much. Also, a big thanks goes to Chamber of Survey Engineers. They let us to open this very nice facility and very big support for this organization. Also to ISPRS, they made this event possible. Also, this is not only the workshop, this is sustainable collaboration. After workshop, we will keep in touch in our portal we developed recently. So we will continue over there to include our knowledge and collaboration and our future discussions. Hope this will be also very useful for our world, I must say, our Earth. So, please, Fulya, you can open the session, and then hope we all enjoy here. Thank you.
Thank you. And good morning. We're welcoming you as Akdeniz University, Hydropolitics Association, and Manchester University for this collaborative analysis of flood events with Earth observation datasets. And actually, I hope that the workshop will be so effective for you and gain to you so many perspectives about collaborative analysis. And actually, we are here for the collaboration together. First of all, our workshop will begin with the lectures of the experts, and I will introduce first expert, Mr. Dursun Yıldız. I want to read his introduction. As civil engineer, he graduated of Istanbul Technical University. He worked as water and energy policy expert and manager at the State Hydraulics Works. He received education in the United States and Netherlands. He gave lectures at universities. Mr. Yıldız served as a manager of Union of Chambers of Architects and Engineers of Turkey and the Chamber of Civil Engineers. He received so many achievements from some institutions, and he has so many publications and lectures. You can give the floor now, Mr. Yıldız.
Yes. Good morning, everybody. Just it is mentioned, this is really a very important subject because yesterday, General Directorate of Meteorology announced that today, maybe when we are trying to explain something on flooding events, somewhere will be flooded. Where? It's highly probable, according to their explanation, if my memory serves me right, is eastern part of Black Sea, western part of Black Sea, and somewhere else will be flooded, because red alarm and yellow alarm, it was announced yesterday. That means that this collaboration and the continuing this collaboration is very important. Okay, no need to talk a lot about that. Everybody will be living in that condition, even in Ankara or Istanbul or somewhere else in Turkey. If you go to outside of Turkey, of course, you can meet this kind of things in different countries as well. That's it. Second thing, thank you very much. This is really important events, and I would like to touch some points which is not so usual together with you today, unusual, because this is not only the subject, this is not a matter of technical solutions, but the solutions related with the politics, as well as human awareness and something like that. I would like to thank to everybody, especially in Chamber of Surveying Engineers, because I used to be a deputy director of the Turkish Chamber of Civil Engineers and Architects once upon a time. And it is really very important to have that kind of facilities to discuss all these things. Thank you very much for them. And it's a very big achievement from my time, because all these things, if you need collaboration needs some certain places just like that. What to do? Otherwise, in our time, there was, well, maybe one or two that kind of facilities was available at that time. But now, I'm very proud of that. We have that kind of facilities to discuss a lot on that kind of important subject. Okay, let's go. From flood control to integrated flood management. I would like to be as quick as possible, because I would like to put my explanations within 20 minutes to maximum 25 minutes, even if they spare me half an hour. I would like to be, as I said before, as quick as possible, because after 20 minutes, concentration is not so much good according to the experts' explanations. Okay. Now, I would like to touch the political and social dimensions of flood risk reduction. There's an alarming rise. Everybody knows that one. Okay. Tamam. Okay. as we have been aware of that during recent years, there has been an alarming rise in human life and economic loss due to the flooding in both developed as well as developing countries. The way we deal with flood co-determines whether water remains a life-providing element or becomes a destructive force against human life. Challenge. Prevent flood hazards turning into the disaster we have seen till now in many times. Okay. We need to increase the multidisciplinary approach in flood management, multidisciplinary, when we are doing here in this collaboration events right now. I'm an engineer, civil engineer, and there are a lot of disciplines here to discuss this point. And the multidisciplinary approach is important. Improve information on integrated flood management approach. Integrated flood management. Integrated water management includes integrated flood management. Be aware of political and the social dimensions of flood risk management. What happens if you are not aware of this point? I will try to touch this point in my presentation as clear as possible. We need to enhance the community participation. Okay, community participation. Is it a matter to reduce the risk, flooding risk? Yes, it is. It is. You cannot prevent or protect flood just only calculating the Q50, Q100 or Q500, because we did a lot in our DSI time in that kind of things. We need to apply all these solutions to the practice, Control of floods. Yes, we need to control of floods. How? Before, the initial interventions have largely relied on control of floods through structural measures. After that, later on, it was supported by certain non-structural measures. From structural measures to non-structural measures. These approaches have been ad hoc and essentially monodisciplinary in nature. We need multidisciplinary. The structural measures have largely succeeded in only shifting them rather than mitigating the floods, mitigating the risk. Okay. It is widely recognized that a paradigm shift is required. Paradigm shift is required. To move where? From defensive to proactive action. From defensive to proactive action. How do you defend yourself when the flood is coming towards you? I will show it to you right now. After 2 or 3 minutes. How to defend you if you made a lot of mistakes on planning, on land acquisition, or on land use. How to defend yourself. It is impossible. No way out. That is as clear as ABC. Okay, then, Mr. Yıldız, are you saying that there is nothing to do? No, I don't want to say that one. I am saying we have to choose the right way to do something. If we would like to put our solutions in the practice as effective as possible, we would like to shift the paradigm. If you don't want, okay, you have to accept all the possibilities which is not so good for all the people who will be lost maybe in a flooding event, or who will lost a lot of poverty in the first flooding event. Okay. We need to towards a culture of prevention by managing the risk of and living with floods. Integrated water management, water resources management includes also flood management and flood risk management. We have to shift from flood control to integrated flood management. Flood control. Let's control the flood. Okay, how to do that one? A lot of measures can be taken to control the flood, but to control the flood requires the measurements at the upstream side of the river, not the downstream side. You cannot control the flood in the city. It is impossible. Flood can be controlled in upstream part of the basin. I will show it to you related with the Bozkurt floods. How to control that one. It's a continuous process. It's required learning from experience and good practice elsewhere. And Bozkurt flood is a very exceptional one. Integrated flood management requires adapting a river basin approach to planning through multidisciplinary inputs. Again, it also strengthens the adaptive capacity to climate variability and change. Adaptive capacity. Adaptive capacity. Which directorate has this capacity right now? DSI? Maybe. Municipalities? Others? Okay. But climate variability brings several obstacles to reduce the flood risks. Why? Because we see that one. Flash floods is very destructive. And also they are coming maybe once in twice years in different places. So what to do? We have to think it over, and we have to maybe change our even calculation and the practice approach. Implementation of the integrated flood management concept requires developing the capacities by supporting local and regional actions. Local and regional actions. This must be supported by a combination of training and awareness building measures. Awareness building. We are all aware of the risks. If you say so, I would say no, you are not, including most of the people under the threat of flooding risk are not aware of flooding risk. If they are aware of flooding risks and some certain problems which they will face during the flooding time, they will behave differently. The flood risk management cycle, you see here, and the preventive measures, protective measures, and preparedness. There are three things: preventive, protective, preparedness. Okay, let's look at closer to that. Risk management pre-event requires prevention as well as protection. When we are talking about the prevention, we are talking about the relocation, planning, development control, regulations, and the property acquisition. And when we are talking protection means structural measures, dams, channels, ecosystem-based measures, or something like that. But we are not able to preventive measures if land management was not so good before. I mean, if you do it wrongly in the wrong direction, it is not easy to change suddenly saying that, okay, reallocation is impossible. Okay, let's take them from here to there. Okay, put them there and let the river flow as free as a bird. It is impossible. So what to do then? We are forced to protective measures. Protective measures. Why we are forced to protective measures? Because of the climatological reason and the social and political reason. Climatological reasons is that change of the precipitation regime and the increased flash floods, increase in uncertainty in water management. It's not easy to be certain in water management anymore. It is not easy. And how about the social and political reasons? Land use planning, settlement restrictions in flood zone is politically unfeasible. Not in only Turkey, but also in some different countries as well. Unfeasible. Resettlement is difficult. Even you are under the risk of earthquake in Istanbul. Earthquake in Istanbul. Professor, somebody said that, okay, within 1 year, it is highly probable there will be an earthquake in Istanbul. What to do right now? Nothing. Nothing. Resettlement is difficult. And also protection measures are more visible to gain political credit. We are solving your problem. When? After the floods. And we lost a lot. Yes, but we didn't know that much water will come as flooding. We didn't know that because it is the first time you have heard a lot of time that one. It is the first time it's coming. We didn't see that one. I mean, to square meter, it is 255 millimeters came, and we didn't know that one. Therefore, it is impossible to protect this one. It is impossible. When they say so, okay, then what to do for them? They would like to recover, and they will put, they will build new apartment for you, and they will say, okay, here you are, please. But nobody will bring the lost human life. Nobody will be mentioning about the lost human life after the flood. Then prevention, protection, preparedness. Prevention to avoid the flood. Prevention to avoid the flood. Protection to reduce flooding. Preparedness to readiness to act. To act after the flood, to save your life or your property or something like that. To avoid, to reduce, and to act. The most preventive measures to avoid flood risks. The most important one. Most preventive one. preventive. How to protect this area? We calculated what happened in Ezine River in Bozkurt. What was the watershed area for them? It is only 375 square kilometers. Only that one. But the flood, how was the flood? I mean, as far as I know, it was 400. 375 square kilometer created that much flood. It is impossible. How to calculate? Okay, if somebody will say that, will you please calculate that one? What is the possibility to come this amount of flood from this area? When somebody brings that much water will come to you, this figures doesn't mean anything for you. No, it is impossible. I mean, when somebody says, Mr. Yıldız, it will come this year, and it is highly probable that will come the year after next year. You can say that it is impossible. How it could be? But they are happening right now. Therefore, the uncertainty is the highest point for the engineers to calculate what will come, how much water will come. Even in, this is 375 kilometers. That is this area, only this area. You see, the clouds are coming and falling, this precipitation here, and it is only 4 months, 4 hours to reach the Bozkurt, and after that flood. But all this area is under the risk of that kind of floods. All this area. That brings us a paradigm shift from zone protection to life protection. You hear that one most of the time. We are happy because we didn't lost any human life. Yes, we will listen all this explanation a lot after the coming floods, because nothing to do except for saving the human life for the time being. Not, of course, there are a lot to do, but for the time being, nothing to do. Save the human life, and after that, let's look at what can be done afterwards. And of course, we have to be aware of that. Flash floods, forecasting methodologies, and early warning to save the life, human life. Early warning not to save the buildings or some others. Bozkurt flood incidents reveals how vital the early warning system is. It is known that heavy rain started around 7 o'clock, lasted for about 4 hours, and it is thought that the peak flow rate of the flood passed through the Bozkurt district's center at noon. And there is a period of at least 2 or 3 hours between the heavy rain that causes the flood and the peak flow. 2 or 3 hours. You have to take some measures, not preventive measures, protective measures. Protect yourself. Protect your life. Obstacles. What is the obstacles to taking disaster preventive measures against floods? Where the question is simple. Where the water management face difficulties for integrated flood management. Where? In which point? That's it. There's a floodplain full of apartments. So what to do right now? Nobody can explain me that, okay, Mr. Yildiz, it is easy. We can take them out and resettlement and let the flow, let the river to flow as free as a bird. Okay, it is impossible. So how can you protect the floodplain? You see, it is 2000, 2010, 2020. Nobody cares about that, if the floods will come or not. Why am I saying this? Because of that. Although there is a flood risk assessment map in Bozkurt City, flood risk, DSI, State Hydraulic Works, most of the time prepares flooding maps and the flood risk maps to say that, please don't put anything here. This is restricted area because this is for floods. Nobody care about that. And after that, we try to prevent ourselves. Prevent, which is impossible. After this flood risk map, there are new apartments have been built, and do you see here? After the flood risk map, what to do as technically, what to do more? And you are calculating, saying that, okay, this area will be flooded. And even these risk maps, you are opening this area for the settlement. Who is doing that one? And who is insisting on this one? Which one? The society is insisting. The decision makers are taking this decision. Not me, not you. Then it brings political and social dimensions of flood risk reduction. Politics and the flood risks and management. The public perception of risk must be in the center of attention. Public perception must be in the center of attention. In fact, perception level different with the expert perception level. Expert is saying that there is a flood risk map here, but your perception is totally different, very far away from the expert points. Nothing to say more. People underestimating the flood risk is a major problem and a challenge in managing it. Underestimating. Lack of awareness is another problem. Lack of awareness is the public's lack of knowledge on potential risks and impact of flooding. This lack of understanding in connection with the poverty, this is important, can lead to a lack of preparedness, and lack of willingness to take steps to protect themselves and their property from the flood risks. This also contributes to another aspect of lack of awareness, which is the public understanding of the steps they can take to prepare for and respond to a flood event. Additionally, lack of awareness can also be a challenge when it comes to understanding importance of land use and development policies that can help reduce the risk of flooding. Land use and development policies. So many individuals may not understand the importance of zoning regulations that restrict development in flood-prone area. And when it comes to understanding the importance of land use and development policies that can help reduce the risk of flooding, many individuals may not understand the importance of zoning regulations and furthermore, lack of awareness, importance of natural flood management measures such as preserving and restoring wetlands and the other natural areas that can help absorb and slow down later. Importance of zoning regulations. Is it important? Sure, important. Of course, important. Many individuals may not understand the importance of zoning regulations that restrict development in flood-prone areas. So what happens after that? That much restrictive results. How to do? What to do? Empowering the public awareness in the face of disasters, education, information campaigns, and involve the community in the development and flood management plans. Involving flood management plans. Not to writing something to send somebody, okay, this is your duty and you have to put this in practice. This doesn't work. Working, this, if we need effective solutions, we have to choose another way. Limited authority. Additionally, limited authority can make flood management difficult for different levels of government. How? For example, if a state government has primarily responsible for flood management, but local governments are responsible for land use planning. Coordination is missing. DSI is saying that I am sending to you flood risk maps. Be careful when you open this area for the settlements. Politically, a social politics dimension of the restriction of this area is not working. It is putting some pressures on the decision makers, saying that, please, be careful, because if you like to be a mayor of this area, the next election is coming within 6 months. And it can be difficult to ensure that development in flood-prone areas is being properly regulated and that the risks of flooding are being minimized. Okay, let's look at the gaps and weakness of flood risk management. Public awareness and the local authorities to implement flood risk zone plans and risk management plans. How? This is the area that who is responsible to clean these areas. This is a canal which is going through a city. Who is responsible to clean that one? I didn't get this answer from nobody till now. Most of the people say that, okay, till that point, we are responsible. The other, they are responsible. Who will manage, who will coordinate it? It's highly probable measure of this city or the governor of this city. But the governor is saying that who is, and they are saying this point after the flood. After the flood. Let's look at. This is not an area for plants. I mean, there are a lot of trees here. This is a channel. You see? Closer look. Who will clean? Who will clean this channel? Which department? And how about that one? How about this? We, as Hydropolitics Association, just after the floods, announced that it is very much important to clean the area opening area to the sea. River mount to the sea. Who is responsible to clean that? This is a survey which was done Exeter University in England. What is that? I mean, how about the results from the survey? Lack of management of the river network. It is important, but the survey results show that about 40% of the responders selected land and river management options as cause of United Kingdom floods, compared to only 11 of selecting rainfall. What are they saying to us is that land and river management options. How about this? Stronger planning rules and regulations to prevent building on floodplains. What is the question? Question is that solutions for flooding. The response is that stronger planning rules and regulations to prevent building on floodplains. Integrated flood management. Lesson learned. We have learned a lot. How about the most important two? Most important one and second one. Awareness of at all level and better and land use planning and water resources management. The others are early warning, post-flood recovery or something like that. These two is important. Awareness at all level and the better land use planning and water resources management. Who is saying so? Global Water Partnership. Implementation is difficult. Political and social dimensions of flood risk reduction measures makes it difficult. Therefore, what to do? The overall effectiveness of integrated flood management doesn't only depend on technical measures. Heavily depends on the mindset of the politicians as well as the general public.
Thank you so much, Mr. Yildiz. And have you got any questions to the experts? Yes, please.
Mr. Yildiz, thank you very much for this very fruitful, exciting presentation. I have a question. I wonder your experience about regulations or the application in Turkey for the existing residential areas and for the ones that are going to start for constructions. Is there enough awareness for new settlement areas by means of flood events, or it is a problem just only for existing ones?
You see, what is the problem? The problem is that one. We calculated the flood risk management, maps by the help of hydrological results, but not taking into account the climate risk. That's the point. They are not before they are not prone to flooding, but today it is. So what to do? Change mind, changing mind, and changing the calculation and just changing the risk map. The borders has completely changed. So you see what to do for changing another changing point? Railways. Railways again. We explained that one. Railways is under the risk of apart from the new settlement area. Even right now, railways breeds under the risk of flooding events. Very big risk. And the last year, two or three accidents happened because of the unexpected precipitation with a very small area, in a very small area. Unexpected one. Therefore, we are not ready. We are not ready. We have already, yes, but the DSI must recalculate, and they take another measures.
So what I see is the flood event in our country is only taken into account with the flow capacity of the area, with some volume that passes through some time, but it's not that only.
Of course.
We have to make some planning. We have to revise our flood maps, and also the awareness is very important, not by means of technical point, but the politics and the public is the vital one.
Why should I convince you to protect your life? That's the question. Why should I convince you to protect your own life? This is a point, social point, political point. This dimension must be included in our evaluations. And maybe some stronger protection measures. Maybe some other things. What happened in Libya? How many lost? How many people? More than 11,000. More than 11,000. Recently, the news was saying that about how many? 1,050 dead body was found in the flooding areas or something like that. 11,000. Only one flood. Showing that lots of TV channels called me saying that if Turkey is under the same risk, we say for the time being, no. But in some certain places, yes. Because most of the time, we are underestimating this new floods, destructive positions. New floods. What does it mean, new flood? New normal. This is new normal. So we have to change a lot of things. Paradigm shift is a must. In many respects. You cannot solve this problem within this frame of thinking. You have to change your mind. The politicians must change their mind. Technical people also recalculate all these things and put the effective solutions, applicable knowledge to the practice. Okay, sorry. Yes. Another, please.
Another question?
One question.
Okay, maybe you can say yes.
If the flood is high in the area, what services should we provide for this area that such places do not flood again, or if they do, then flood less?
flood, if the flooded area, you have to take some measures in the upper part of the basin, and the lower part of the basin there is nothing to do, because it is so unexpected flooding results. I mean, flooding discharge. Nobody is expected. Most of the time you see that we are not expecting that much of flood. Okay, so what to do? First of all, you have to calculate the level of risk. But if somebody can calculate this level of risk and to bring it some decision makers can easily ask that, what is that one? It is impossible to find a financial solution, this structural measures. So the measures must be protective measures, protective the life first of all. The secondly, to try to change the awareness, social awareness, and they try to put the third one and the changing the mind of the politicians. Nothing else.
And thank you. Thank you, Mr. Yıldız, so much for your presentation, impressive presentation, and thanks so much for the questions. And the second lecture is about atmospheric and meteorologic nature of the flood events. And I want to introduce Dr. Doğuşan Kılıç briefly. Dr. Kılıç is postdoctoral research associate at the University of Manchester. He has PhD degree from environmental science at ETH Zurich and Master of Science degree from University of Bern, Department of Climate Sciences. And the floor is yours now, Dr. Kılıç.
Thank you very much for the introduction. Hello, everyone. I'm very happy to be here, to be in the Turkish capital, Ankara, to meet you all. And I'm also very happy that we have professionals and organizations like yours to communicate the science we do to policymakers. By using this courtesy, today I'm going to talk more about the theoretical part of the floods. It was actually a little more than a year ago. Nusret told me if I can tidy up a seminar, sort of an introductory presentation for geomatics professionals and researchers on the structure of the atmosphere. And today, this is what I come up with. It's a pity that I am the person between you and the coffee break, but I promise I will try to hasten my pace and to make it faster. Here we go. Yeah. Yes, I am a research associate at the University of Manchester. Currently, my studies focuses on aircraft emissions, but I was fascinated by climate and atmospheric science since my early career, and I worked on climate modeling mostly during my master's. As I mentioned about the atmospheric structure and the presentation that I prepared for you today, you see the outline. I'm quickly going to talk about the atmospheric structure, more specifically the composition, the layers, and circulation. Then we are going to talk about the local mechanisms of the rainfall and how a changing climate impacts the extreme weather events. And finally, I'm hoping to provide you some library information when you're looking for the atmospheric data that is relevant to your studies. So, as you all know, the atmosphere consists of a few layers. And currently we are living in the lowermost bottom one, troposphere, which extends during the summer times, which shrinks during the winter times, which also expands when it has high solar radiation around equator, and it shrinks to roughly about 60 kilometers when we go up to the polar regions. And here, you don't see the cursor, right? So, do you see it now? Yes, nice one. So, we live in troposphere. It's the lowermost layer, and on top we have stratosphere, where we have ozone layer, followed by mesosphere, thermosphere, exosphere, and in between we have ionosphere here, where you can find molecules, but you find elemental atoms, mostly the ions. They're all charged. Only here the first satellite starts to appear, and on the right you see the change in the air density. So actually about 75% of the total atmospheric mass is in troposphere, and almost all water vapor and the particles also exists in the troposphere. So troposphere also has most of the meteorological events takes place in troposphere, and most of them originates here. The right you see the intensity, air density. So here at the troposphere level, the free path for a molecule is about 10 to the minus 7 meters. So consider that I am a molecule. I only go about like 10 to the 7 meters, which is, if I'm not calculating wrong, it's about nanometers. So in nanometers, I meet another one. But like if I go to the top of the atmosphere, since the density decreases, this path increases up to 10 to the 7 meters, which is thousands of kilometers. So one molecule or one ion has to travel that much at the other edge of the atmosphere to go further. Then one point that I have to mention, in the middle you see the variability of temperature by the changing altitude in the atmosphere. So in the troposphere, for every 100 meters, the temperature decreases about 0.65 degrees Celsius. And this we call adiabatic lapse rate. So this change is thermally, or it is energy-wise isolated. But you see an increase here in stratosphere, and you see an increase here. So the reason for the increase at the top is because we see the photodissociation of the molecules over there. The solar radiation over there we receive is below 170 nanometers. And if I come down to the stratosphere, where we have ozone layer, and this is why we have the increase in the temperature, the solar radiation reaches here is about 240 nanometers, which is enough to photolyze oxygen. So I was hoping this to be a little more closer, but like I quickly show the ozone formation over there is. So one oxygen molecule with the UV, this UV is 240 nanometers, and then you form two excited oxygen ions, and these find with a colliding partner. This is actually an M, and then you form ozone. I didn't draw the net equation. I'm pretty sure you will find better drawings than mine. But this results in the energy release, and this is why the temperature increases. So the next stage is, what is this M in the middle? So if you're talking about Earth's atmosphere, it's most likely nitrogen, because atmosphere consists of about 78%, 78.08 nitrogen, which is followed by about roughly 20% oxygen, 1% argon, and the CO2 that we are concerned about climate change is only about 0.04. So it's at ppm level. However, the increase in this number leads to dramatic changes in troposphere and upper atmosphere. So if you go to another planet, you won't be able to find the mechanisms to form ozone, or water won't exist. Here on the right, there is another neighboring planet. it's the Martian atmosphere is shared here. So the Martian atmosphere mostly consists of CO2, you have some nitrogen and some argon. However, the water over there and oxygen there is less than 1%. So in Earth's atmosphere, we have about 2% water vapor. And this changes locally. So plus minus 2, 0 to 4%. So where is this water in the atmosphere? If we track together by looking to the world map here. So of course, by looking to the vegetation, you see some green parts over here, some greens over here. So if draw these lines, one is the equator line, which is around 0. You see a lot of greeneries here, which signals that there is a lot of rain here. Then if you go from tropics to the subtropic regions and draw another line at 30 degrees, you see that these regions are arid. Do you think this is a coincidence? I imagine you're not. So George Hadley taught as well, and he mentioned about a Hadley cell, a cell that takes the water and circulates it around the atmosphere. And he did that in 1735. And there is another line over there at 60 degrees that we see, and it's also green. So if we have a look at the cell that he proposed earlier, so he mentioned about because of the rotation of the Earth, because of the Coriolis force, so we form 3 cells and jets in the atmosphere in between the troposphere and the stratosphere. And like a few planets in solar system, Earth has these solar jets, atmospheric jet streams. So the first one is the Hadley cell here, which shows like equator gets the heat. It's like frying or like boiling water in an oven. So the air starts to rise with the warm, and this warm humid air rises, leaves the water below, and the dry air goes to 30 degrees. So the same we see over here at 60 degrees. However, the dry air, only the dry air comes to the 30 degrees latitude. So if I go back to here quickly, this is what we see over there. So there is one thing that you will realize, I guess. So this line pretty much shows the deserts of the world. However, we still see some greens over here. So this is fascinating about the Earth. The crust, the geology sometimes dictates the rules. This is the local effect. What do we have over there? There we have the chimney of the world. Okay? Yeah. There we have the chimney of the world. So this is what the highest place on Earth. So what happens there is the humid air from the ocean comes, meets the mountains here, the mountain shed over there. So it's rather mechanical. It's forced to go up and leave all the rain to the side of the ocean side of the mountain. So what happens? The dry air reaches behind the mountain to the Tibetan plateau, where it's quite dry. So this is because of the shape of the crust. This is because of the topography. And there are a few other places which changes the rule that we are going to talk in coming slides. So what we have to keep in mind, why did I talk about all these slides? If you want rain, physically, you need upwards motion. So the other thing that you need is, you need gravity and the condensable water. So to rain to form. You need water droplets and a surface that water can condense on to form a cloud. From our daily lives, with 2 observations, we can see this easily. One is the cold water that we get at the room temperature. What happens there? If I get a cold water, if I put it here, if the room is warm enough, and if it has some relative humidity, some water vapor, the water will condense on the glass, and you're going to see it, because like, what does it provide? This glass provides the temperature gradient. Temperature of the room will be higher than of the water inside it, to surface to condense on. This is very similar, physically almost identical to the contrail behind an aircraft. So what happens? An airliner releases during the flight the particles and water vapor together. And inside the combustion chamber of an engine goes up to 5,000 degrees Celsius. And these airliners fly at top of the atmosphere, top of the troposphere mostly. So where we have like minus degrees of Celsius. So we have temperature gradient, we have particles to provide surface for water vapor to condense, and then we also release water vapor from the engine. And this is why we see these beautiful, or in quotes, beautiful artificial clouds behind the airliner. So in the atmosphere, of course, it's not only the artificial sources that provide particles. We have sea sprayed salt, desert dust lifts from the arid regions. Even bacteria and pollen serve as a cloud condensation nuclei for clouds to form. And from here, we go to a local scale. So in local scale, I tidied up the types of the rainfall that we see within this altitudes, or namely in Turkey, we can say. One is the convectional rainfall, that you see it mostly during summertime or early autumn. What happens is the sun hits the land, it generates rising air parcels with warm air, then they move upwards. And this is called the convection current. The warm air rises rapidly, starts to cool down, and condenses to form clouds. And these clouds mostly come with the thunderstorms. You hear them because you form nimbostratus clouds mostly, and they can potentially bring a lot of rain. The second one is the frontal rainfall, which happens when there is a wind direction dragging one warm or cold front to the other. So in this one, I wanted to show the cold front meeting the warm one. So what happens here is, with the wind, cold air comes. Because it's dense, it pushes the warm air in front of it to go up. So it generates the upwards movement. So this upwards movement forms clouds, and then rainfall forms. So these type of rainfall also have potential to bring a lot of rain. And finally, that we see a lot in both sides of both south and northern parts of Turkey, the orographic rainfall. So what happens there is, this is rather more mechanical, as I mentioned, the monsoon region earlier, the Southeastern Asia. So at the when warm and moist air is forced to go up hills because of the topography, the air cools and condenses, forming clouds, and most of the rainfall is lost there. And at the back of the mountain, you receive the dry and warm air. A good example is the Andes in Peru. So these mountains, the rain shadow side of the mountain is the driest place on earth. So this is in the southern America. So the continent-wise, I remember reading during my bachelor the very first IPCC report. If I'm not wrong, that was from either 1990 or 1992. And at this report, they were mentioning about the increase of the intensity of the extreme events. So they were saying that what climate change will bring is the increase of the intensities of the extreme events. So you will need to redesign your structures. Maybe for there will be an expert after me. There will be interesting talks after me who will have a better saying on this topic. But like these designs were made like rainfalls returning, for instance, every 20 years. So they were talking about like we need to renew this because these rains will come almost every second or third year. So they were right. Only after the 14th of September this year, in all four continents of the Northern Hemisphere, we experienced life stopping, like with casualty, the flood events with life stopping and casualties. So we saw this in Turkey, we saw it in Southern Europe, mostly in Mediterranean basin, as Mr. Yildiz mentioned earlier, in Libya. It was just either yesterday or the day before we saw it in New York. So what happens is, with the increasing tropospheric temperatures, we increase the sea surface temperatures as well. So what happens? Increasing sea surface temperatures provides more water vapor to the atmosphere. And we also emit aerosols with the anthropogenic activities. More aircraft are flying every year, or we emit more aerosols to the atmosphere. So by feeding atmosphere with the two important components increasingly, one is the aerosols, which acts cloud seeds, two, the water vapor. By increasing sea surface temperatures, we actually serve a perfect environment for rainfall to increase or for extreme events to increase. So with this slide, what shall we do if we would like to monitor the change of these events, or if we would like to compare a current event with an event from the past? So there are data sets available, and I classified them under two groups. One is the observational data that you see on the left, and the other is the gridded reanalysis data. The observational data is in situ measurements. It has high precision, high accuracy from a point source. It's a local data set. It's ground truth. So it's the reference. But this data is sparse and scattered. For instance, I mentioned about this IPCC report earlier for policymakers. And at this report, one of our colleagues calculated the total surface area that these in situ sites measure all around the world. The area that we measure actually is at most as big as this building. So by using these point sources at different locations, we produce the gridded data, the reanalysis data sets that I mentioned on the right. Of course, we make use of satellites and numerical weather models for interpolation. So there are three, to my knowledge, there are three globally used data sets. One is the European Center for Medium Range Weather Forecast, if I'm not wrong. The ERA 5, the very final version. The second one is the NCEP-NCAR. This is the National Center for Atmospheric Research, US, National Center for Environmental Prediction, if I'm not wrong again. And then we have CRU from UK. So here, I also included a slide, but I don't know if I will manage to open this. Let's see if this works. So if I don't see it. Is there any chance you can help me to show this? Buna bakabilir miyiz? Okay. Okay. like this. No.
You should close the presentation.
Mhm. Yeah, it's just to turn it off, you know. Yeah. Just turn it off.
No, paylaşmıyoruz zaten, sorun yok.
Hı.
Bunu açmak mı istiyoruz onu anlamadım.
Evet. Aha.
Direkt basabiliriz üstüne.
Bastım, açılmadı. Normalde burada. Never mind. I am just going to be posting this. There is a link for you to access. So what you have to do is just to register there, and the data will be in two formats. One is GRIP, the other is NetCDF. So you will need some soft skills to be able to analyze it. The GRIP is the early version. It's not a really well structured data, but like it's an old version. So some people, some offices still use that one. The second one is the NetCDF data. It's more organized, very recent one. Most of the people use that type of data, but you will need a library to be able to analyze that type of data. And with this one, do we have time for questions or? Okay, so then there will be another interesting presentation after me. Dr. Kubilay will be talking about a field example, and regarding the specific topic of today, he will be talking on the Bozkurt flood specifically. I guess we have time for questions, right? Yeah. So I'm happy to answer your questions if you have any. Yeah.
And thank you so much, Dr. Kılıç. Any questions about this in-person presentation? Yes.
Thank you for the presentation. How often do you think we need to update the flood risk maps based on your climate change observations? So we know that we have to update the flood risk maps, but how often?
Mm-hmm. Yeah, good one. So I use IPCC as the reference, or the state-of-art, very recent climate models as a reference. And over there, they were estimating of about a 2 to 4 degrees Celsius increase in the atmospheric temperatures for every 10 years, for instance. And they were also predicting, based on this assumption, how will be the return time change for some threshold levels so that we design our dams or water discharge systems. And I guess the worst scenario is occurring currently. I show you the map. There were 4 or 5 scenarios. So I would use the worst case, and I would check for every 10 years. I don't know the, how do they say, concrete life of the construction wise. Probably Dr. Kubilay would tell you more about this. But I would, my personal opinion, to my knowledge, I would use IPCC as reference and would do this check every 10 years.
Thank you. Another questions? Yes, please.
Perhaps a contribution to Dr. Doğuşkan said and the previous question. The service life of structures are also another debate or discussion, which is very important. For this, for the current legislations, the service life of a structure is around 50 years for Turkey. But as your economic and wealth income increases, this number increases to 70 or 100 years, which is a good thing. So when a disaster comes and you have some damaged buildings, then you have to renovate them or rebuild them. This is very expensive. So to increase the service life of structures is an expensive investment at first, but is a very clever one also, because you don't have to renovate them after each damage. So if the flood risk management maps are, let's say, yes, in every 10 years, it's a good thing.
That's the expert opinion.
And I have another question to ask. Do you have any estimate of the development of floods? I mean, is it the frequency that is increasing or the magnitude only? For
Yeah,
the,
exactly.
or both of them,
Yes.
or is it random? I'm just
Yes.
it's my curiosity.
It's to my knowledge, both. So, but we see more, let's say, heavy rain of like 50 millimeters per day. Maybe I can talk about Antalya, and if there is any other expert who wants to correct, please feel free. Both the number and the intensity increases. That was also predicted more than 10 years ago.
It really depends on the regional phase, yeah.
Yeah. Mid-latitudes, I'm just talking about mid-latitudes, yeah.
Can you explain the intensity?
Yeah, the amount of rainfall you get per square area.
How long
I mean, per day.
per day?
Yeah.
But most of the time, they are explaining that one. In square meters, we get 100 or 150 millimeters rainfall. Most of the time, they don't say in which time, in 1 hour or 2 hours or 3 hours, and this is very much important because of the hydrology of the floods. Flood hydrology is important. I mean, they are saying that today, yes, we get this amount of rainfall. Within which period? Today, does it mean that 24 hours or today within 2 hours? Most of the time, they skip out that one. Because the hydrology, you see, hydrograph, it's coming and there's a T at the bottom. So very small. So the intensity will be much more higher in that case. Well, when I say intensity, of course, should include the time. I mean, the time interval.
Mhm.
Maybe this intensity is changing as well. Because of the rain intensity includes also this time interval,
Yeah.
isn't it?
Yeah, definitely. I mean, I'm pretty sure a hydrologist would provide a better answer for this, but I just don't want to be the person to stop people go get their coffees. I will be around during the day, so if you have any further questions, I will be happy to answer. Thank you very much.
Thank you so much for the questions. And now we have coffee break, 15 minutes, and then we can go on to the lectures.
Okay, can everyone see? Okay. So today my presentation is about the damage assessment and evaluation on the Bozkurt flood. After 2 days of the flood, it was August 11th, the flood event occurred. After 2 days, we went to the site with a colleague of mine. So we are the earliest ones that have reached there as researchers, of course. And after that, the data we have gathered, we published a research paper in Natural Sciences with lots of my colleagues, my esteemed colleagues. I would like to mention them here also with Rasim Temur, Sezar Gülbaz, and Nurdan Apaydın, Melek Kazez Yılmaz, and my geotechnical colleague İlknur Bozbey. Most of the data that I will present today is taken from this publication. So I like to mention them as well at the beginning. So I made a quick search in the internet, and even this month, there were lots of floods all around the world, in every continent almost. Let's say in Brazil, in Turkey, in Japan, in Libya, of course, in South Africa, in Mexico, we witness a lot of floods. So it is a very actual and an important event that we have to deal with as engineers. So today, there are very expert engineers from different areas. So the main idea is to prevent, control, or mitigate the risks of flood. And if we don't really take care of the flood event, the cost of the flood is also increasing. Even the last year, $224 billion of cost all over the world occurred due to flood damage. So it's a huge amount of money as well to the economy. So we have to take care of flood event and develop some new measures and new techniques, and also perhaps new codes to prevent or to mitigate the flood risk all around the world. So specifically, if we begin to discuss about the Bozkurt event, the event occurred on August 11th. It was one of the most destructive flood disaster occurred in the western Black Sea basin of Turkey. After the flood, 76 of citizens were lost their lives, and with an estimate of 30,000 people affected from the disaster. The maximum precipitation reached up to 400 millimeters per day, and this is at least the flood occurred at least during a 500-year rainfall event. So we describe this event as 500-year rainfall event. During a 2-day site, immediately following the flood event, damages to infrastructures. Since I'm a civil engineer, our main topic was the structures. The infrastructures, water structures, bridges, revetment walls, or flood walls, we can say, highways and residents were our focus. We made a site visit to Bozkurt and Ayancık. Bozkurt and Ayancık, you will hear a lot about these districts, is at the northern part of Black Sea actually, but western part of the Black Sea region, northern part of the Turkey, western part of the Black Sea region. So you can see the watershed area of Bozkurt is this one, and Ayancık is this one. But my focus today will be about Bozkurt. Bozkurt is a district of Kastamonu, is located at the Black Sea region. The altitude of the region above sea level changes between 27 meters to 400 meters. Actually, not that much high, a moderate level, I can say. The population is about 10,000, depending on the data of the Turkish Statistic Institute. The Ezine stream, which crosses the district, flows through Bozkurt region with a watershed area of 375 square kilometers and reaches to the Black Sea downstream. So this Ezine stream reaches to the Black Sea, passing through the Bozkurt district. According to the General Directorate of Water Management, a total number of 40 flood events in Kastamonu and a total number of 37 flood events in Sinop are reported between 1963 and 2016. So this is not a new event for this area. This area is known as a flood area. So this is not a new event in the area. In fact, only one major flood event in 1964 in Sinop was observed until 1983. But after 1983, the number of events increased. So this is related, this is easily can be related to the urbanization of this region. After the event, we collected the data, of course. There were 4 rain gauge stations at the area for the Bozkurt, and the data gathered from these stations are in the table. For instance, Abana, which is at the exit point of Ezine stream, it's around 200 meters. Mamatlar is within the forest area. This is the highest one, the peak one, 400. And Kuzköy and the Devrekani are 300 and 100 almost, with an average weighted rainfall of 300 millimeters per day. According to the General Directorate of Water Management plan in 2015, the flood flow rates of Ezine stream that we are talking about, 500-year flood corresponds to a 384 cubic meter per second. 100-year is 289 cubic meter per second, and 50-year is 245 cubic meter per second, using the flow gauge station located at the downstream of Ezine stream watershed. So we made our calculations. Our hydraulics group made the calculations, and from the eyewitness videos, we measured the speed of the flood as 7 meters per second, which is very high, and the flow capacity as 560 cubic meter per second, which is way much than the 500-year event. So, yes, exactly, more or less. So let me briefly explain you the Bozkurt district. Bozkurt district is at the basin of a valley. It's at the bottom of a pot, okay? This is the basin of a valley. There are lots of factors, of course, influencing the flood event, but we have to understand first, as engineers, the stream, the topography, the structures. So this is the basin of the this is the aerial photography of the area. We made a key plan. In our study, we made a key plan. We divided the city into grids, okay? This is the egg. Can you see my cursor? Here, yes. So this is the entrance of the Ezine stream to the city, and this is the exit point, okay? So there are 2 branches here, one from this left, the one from right is also given here in this one, and the flow directions are this way. So just keep that in mind, okay? Now, how did the flood progress in the city? Okay, let's discuss it. The flood carried lots of trees and logs from the forest, which entered the city from B1 and C1. So here, this is the entrance of the stream. So the logs and trees the sediment came from these 2 branches. A pedestrian bridge named B5, the pedestrian bridge is here, is destroyed after some time, which is a very light structure. It's being dragged from this direction to bridge B5. Bridge B5 is a reinforced bridge, which is a strong bridge. But the deck, döşeme, the deck of this pedestrian bridge, which is washed away, blocked this bridge, bridge B5. So this bridge dragged here and blocked the clearance of this bridge, and the water is blocked here. So the sediment coming afterwards from the upstream, since blocked by bridge B5, bridge B4, flowed into the city. So keep that in mind. The structures, the shops and the commercial area, the residents are here, which is C and D areas, C6 to C4. So since the path of the stream is blocked, the water flow through these residential areas. I will show you the videos. Immediately after that, in 5 minutes, lots of people lost their lives since the water changed its direction to residential and commercial areas. So let me show you the video so we can easily understand how this flood event progressed. Can you see the videos? Yes. Okay, the first sequence that I'm going to show you is from the beginning to 1.4 meter is the entrance of the flood to the city. So at that period, let's continue. At that period, the capacity of the stream is fine up to that. You see the sediment. Do you see the bridge is destroyed? Let's see again. Sorry. You see this? This is a very light structure. It's already destroyed. You will see that it's not shattered. It's still consistent as a solid deck, but it prevents the back material, back sediment. You see? It's blocked. Now, as this deck reaches to the bridge B4, you see here, the bridge B4 is here.
Approaching with enormous force.
Yes, exactly. Ne oldu buna? Allah Allah. I'm sorry. So the bridge deck is already there. The sediment is accumulating right now. The guy that shooting the video is also pointing out that. You see the amount of sediment that's coming afterwards? It's increasing. So at that moment, the flow direction of the flood changed through the city, through the district. You see the backwater effect also here, the backwater effect. Can you see the water is passing through this direction to the right, but it's not passing to the left. Why? Because the west side of the district and east side of the district has different elevations. West side of the district is 3 meters higher than the east side of the district, which is a key factor. By the urbanization, if you are dealing with the urbanization, then you have to consider this. If there's a flood risk, then the city must not extend to the east side. It's the basic logic that the city has to extend to the west side, but this is not the case here. So let's go to 3 minutes and 40 seconds. 3 minutes and 40 seconds. Now you see the flow is within the stream still. After a few hours later, as Mr. Yıldız's presentation told, this is a couple of hours later. This is the original stream bed actually. You see, the engineered stream bed is not enough yet now. All the city is under flood. Pay attention to this yellow building, this one. You see, this is the original riverbed. Okay, but this is not the worst case. Let's go to the 5 minutes. You see, here you can see the trees. But let's go to 5 minutes. There is no tree here. All
It's flowing in the floodplain.
Yes, exactly. Yes, that is. This is a couple of hours later. So as time passes, the event of the flood exponentially increasing. And you can see the rain is in the city right now, because you see the rain clouds, it's gray, the air is gray. But at the beginning, the flood is coming from the forest side. Now the rain is in the city. So it's moving through the district. And after, let's go to 6:15. This is the end of the flood. Sorry. This is the end of the flood. Okay, I have to be quick. Let's go to video 2. This is a zoom out video for the bridge B4. Can you see? Do you know what beavers do, Kunduz? They build some dams to block the rivers. This is what happened in Bozkurt. The direct sediment blocked the bridge, and the entire city went under flood. So, okay, we have to cut brief. So the west side of the city, which is on the left here, is 2 to 4 meters higher. So most of the buildings here did not have any damage. But the buildings here, almost totally, all of them has some kind of damages. The first or the second floors of these buildings have taken damage.
Why did they choose the right-hand side for settlement?
Well, that's a question that I asked to myself also.
Because it's flat.
Exactly.
Yeah, because to get the flood. To get the flood.
No, it is flat.
It's flat, but to get the flow.
Yes, it's flat. It is easy to make construction, but yes, as you said, they had to choose the west side, but it's up to hill, which would be much safer. But the other side is much easier and economic. Okay, not only the choice of the city, the growth of the city is wrong, but there is another critical mistake that is done, is the riverbed and retaining walls along the river are poorly engineered. The 4 residential buildings, B2, B3, B4, and B5. Please pay attention to these 4 buildings because I'm going to discuss them in a minute. They are damaged. The industrial area here is totally damaged. They suffered from significant damage due to retaining wall structural damages. Okay, we will talk about them in a minute. This is the map that we asked from the General Directorate of Mapping, Harita Genel Müdürlüğü. We had to write a lot to them to ask. In 1968, the original riverbed was something like this. And this is the right-hand side is the 2021. So you see these small yellow lines are taken from the original seabed, riverbed. These are the scored areas. These are the collapsed buildings. You see, actually, the river is always river remembers its original riverbed and tends to go there. As we built the district on the original riverbed, then the floods will always go to those areas and damage the buildings that are constructed there. The residential areas exposed to flood in Bozkurt region are located in the original stream bed. You see here, also here, where the channelized river in 2021 bed capacity was exceeded. The original stream bed had a meandering shape with curves. So this meandering shape tends to return its original position with severe signs of score. Score means oyulma, This finding is supported by the scoring locations compatible with the original stream bed as given in 2021 web with solid red zone. You see these red zones are scored areas due to meandering effect. Meandering effect causes big momentum fluxes on meanders, which causes big reaction forces exerted on the fluid by the structural components or soils lying under structures. So these additional forces are acted on the structure or the soil, original soil, and then they wash away the soil to cause damage to the structures. The water passages through structures such as bridges, culverts on the stream bed were blocked. The deposits of trees and sediments resulting in capacity losses in cross sections. Clogging the bridges causes backwater effect. As you see, the bridge B4 is blocked and the water behind this bridge rises and it topples this bridge. Not only topples, but goes through both directions. One of the major problems was the foundation levels of the structures were below the stream bed. So this is an illegal operation. I mean, according to our codes, the foundation of the structure should be 1.5 meter higher than the flood level.
What is flood level?
Yes, flood level is another discussion. It's 100, 500, but it should be higher than the flood level, 1.5 meters. It's below already. It's below water level. Okay, I can understand if it is with special precautions, you can build it below because it has also some other advantages I will show you. But according to the recent codes, these buildings should be above the flood level, but which is not the case. This picture is like a lecture to all of us. In this lecture, you see a flooded area. I couldn't find the previous picture. If I could, it would be very clear. But there were some retaining walls here on these lines. This is the retaining wall A. This should be retaining wall B, and this should be retaining wall C. And there was a traffic road here. So the river was here, and there was a road here with cars moving. The pedestrians are walking. This retaining wall B and this retaining wall C was to make the flow of the traffic. And this is for the riverbed, okay? There are we have taken 3 locations on this section. Location 1, location 2, and location 3. On location 1, all the retaining walls were washed away, toppled, or had structural fail, separated at joint planes. So this is a retaining wall. This is also another retaining wall, okay? These are concrete retaining walls, reinforced concrete retaining walls. And the ones that at this line were masonry walls. Do you know what masonry wall is? Yığma duvar. A retaining wall is with reinforcement, betonarme duvar. You see, if you construct a retaining wall, let's say a flood wall, as a wall in your garden, then this wall will collapse. It's for sure. For flood walls, we have to take additional precautions. The depth of the wall should be a few meters higher than a regular wall because it's constructed for the flood, not to carry the traffic load over on it, okay? We have to protect the riverbed, not the traffic on, of course, the traffic on the retaining wall, but the basic idea is to protect the riverbed. So these walls should be embedded much deeper compared to a classical wall. If you construct a retaining wall here, the one that you are going to construct in your garden, then this will be the case, okay? In the old Bozkurt area, in Ayancık area, the flood walls that we have seen was destroyed due to this reason, because they were scored. Okay. The photography taken from L2 location shows no leftover of retaining wall B. There is no wall here. The entire wall is washed away. So masonry walls, we have to consider that masonry walls should not be a good type of retaining wall for flood areas. The entire wall is washed away. Okay? Only the concrete basement of this is the concrete basement. I mean, the basement that we first put before constructing the gravity wall. The bedding concrete of the retaining wall B, gravity wall, was still visible without any sign of scoring. So here, there were no sign of score below the bedding, but the entire wall was washed away. So here, but in L1 location, here, the previous one, there was a sign of score behind the, below the foundation. Here, L2 location shows a collapse retaining wall section where it's probable that driving forces behind the retaining wall increased. In this case, this is the industrial area. In this case, the flood moved behind the wall and washed away the stones of the wall, okay? In this case, not from the in front, but from the back of the wall, it's destroyed. Okay. But there was one area that perfectly worked. It's by coincidence, it's the area that on the west side of the district. This area, the flood structures was protected with a mass concrete wall. So this is the reinforced concrete wall, this one. And also they built a concrete block in front of this retaining wall, and it's here. So during the entire flood, this type of retaining wall worked perfectly because this concrete block prevented the score event. No scoring occurred due to this mass block. And the retaining wall, the yellow one behind the mass block, worked perfectly. Okay? So this is something that we were very happy as engineers when we saw that. We were very excited and promoted that type of retaining wall as well. I have put some pictures for different type of. Let's say this one is a retaining wall. This one is a reinforced retaining wall. This one also a reinforced retaining wall. This is a gravity type of retaining wall. All are collapsed. But this is not a new event. I mean, the design of flood walls have already been discussed and come to some decision. I mean, there are lots of different types of flood walls. You see, on the water side, the main idea is to put the retaining wall to a deeper embedment, okay? If you can't, then you have to prevent the front part from scoring by making some additional precautions, okay, with respect to scoring. We can do a flat basement and a sloped basement, a more depth embedment if possible, or also we can use some concrete buttresses, or as I show you in Bozkurt, mass concrete sections could be designed. All could be done, but unfortunately, it was not the case for the Bozkurt. The observed damage to structures The first one was the residence. If a water velocity of 3 meters per second acting over a 1 meter depth is produced, it is sufficient to exceed the design capacity of a typical residential wall. But the flood speed in Bozkurt was 7 meters per second, and it was not 1 meter, it was 6 to 7 meters. So all the residential buildings were damaged due to infill walls, dış duvarlar and iç duvarlar, I mean, the structures. Collapsed infill walls are the most common type of structural damage that we have observed. And also, damage due to score was very common to observe. Local score of foundation, which caused non-to-particular partial structural damage below the foundations. You see the score here, and the entire building is suffered from score, but the foundations are rough foundations. You know, rough foundations are monolithic foundations with high thicknesses, so they behave like a cantilever. So they are since the structural load is not too much, so they can behave like a cantilever to some point. And damage due to score, which led to partial or total collapse of the building. So these are the B2, B3, B4, and B5 buildings that I have mentioned to you before, and also B1. The reason that this building, B1 building, is collapsed because the flood wall in front of these buildings were totally collapsed. 35 meters far from this building, there was a retaining wall here. Since the retaining wall is washed away, then afterwards the alluvial clays, silts, sands, and gravels, which is not a rock, okay, are washed away, and all these buildings are collapsed. In this case also, all the buildings were located on shallow foundations. Shallow foundations means not too deep, okay, not too deep, on loose alluvial deposits, which consisted of loose clay, silt, sands, and gravel. The three collapsed buildings were approximately 12 to 25 meters far from these walls. Okay, oh, sorry. This is a safe building, okay? Since the revetment wall or the flood wall is stable, this building is safe. But if this flood wall is collapsed, then three things can happen. First one, the building, the ones that we see in B1, B4, and B5, the building can partially collapse, okay? Since it's shallow foundations, since the structure is founded on shallow foundations, this section can collapse. And if the score is too much, then the structure can totally collapse. But if the foundations of the structures are deep enough, then like in building 2, B2, the structure is solid there with no signs of damage, okay? So since it's mentioned in the code that the building foundation should be 1.5 meters higher than the flood level, sometimes can be exceptional. If the foundation is below the flood level, then there should be no risk of scoring below the foundation soil, okay? The foundation soil should be stable and strong. There is also some rumor that we have talked and we have heard there. Some local people argued that there was a discontinuity in the retaining wall of this area due to logistic and shipping purposes. There was a gap here. So the retaining walls were not continuous. There was a gap for transportation purposes, okay? So this discontinuity probably accelerated the overflow of the flood, and cause the loss of stability on the retaining walls. So this is another possibility. What happened to transportation network, the roads? We have observed three different issues. The first one is the major collapse caused by flood water hitting the road platform, the first one. So this is the road here, this is the road. The flood came and hit the road platform and destroyed it totally. The second case, the partial collapse of the asphalt damage due to deposits on the road platform. You see, this is a partial damage. This is very important because you have to find some path to go to these areas. And if all these roads are collapsed like this, then it's a problem. In the first action, all the transportation authorities were trying to reach the area, so even the partial collapsed roads were used as an emergency situation. In the third one, the culverts has insufficient capacity, and they also destroyed menfezler. They also destroyed the road up to a point. Bridges. There are lots of bridge cases that I can show you. The bridges over the main arteries were designed considering the 100-year flow depth, because all these bridges were constructed 40 years ago. So the codes that were at that time were according to 100-year flood, but now they are built for 500-year flood. So piers damaged, decks damaged, pier damage, deck damage, pile damage. There are lots of damages. But a certain case that I would like to mention you. This is the Ayancık Bridge. There are 4 bridges, 4 piers, Pier 1, Pier 2, Pier 3, and Pier 4. And this is a Gerber beam superstructure. The piers has oval geometry due to reduce the score effect, which is a very wise thing. The foundations were not on piles. The stream bed has a curved geometry with an estimate radius of 350 meters. This is what I am telling you. The curvature topography of the river causes something that we couldn't understand at first. But after seeing this video, please pay attention to the logs that coming from the right side of the river. There are no signs of logs or little. Most of them are accumulated here on the closest side to us. You see here. This is the centrifugal effect of the river. Since the river is curved, the sediment and the logs that are coming or flowing, they directly hit to Pier 1 and Pier 2. You see, this is Pier 1 and this is Pier 2. So the centrifugal effect of the topography due to this curvature, which is a slight curvature actually, it could be sharper. This slight curvature could cause additional lateral forces. Could cause additional forces and damage Pier 1 and Pier 2. Nothing happened to Pier 3 and Pier 4. So this was another effect that we have observed. This is the view of Pier 1 that has very severe structural damage. So I have lots of conclusions, but we are out of time. That I have told most of them. Yes, we have to do our design according to 500-year flow. We have to reduce the flood flow damages by making best management practices. It's important to establish an early flood warning system, and retaining walls should be designed as flood walls, not as a garden wall. The foundation depth is very important. The countermeasures for the foundations of retaining structures against score should be adequate. And the major collapse on the road was observed with a direct impact of the flood. So we have to protect the roads by making good design for flood walls. So this is the most of the thing that I want to say. Okay.
Thank you so much for this informative presentation. Actually, food is so important. And we shocked again and again when we see this massive force actually. And actually we can understand this, why the science, all the multidisciplinary science is important to understand all of the flood events and manage the future actually. Not only natural science, political science, social sciences, engineering sciences, everything are so important to manage the future. And thank you so much for all these impressive presentations actually. Have you got any questions to the expert? Yes.
Thank you very much. Really, it was very informative and understandable.
Thank you.
But informative and understandable, but it was very sad.
Yes.
So we are very sorry to
It was also blocked by the flowing sediments. So the problem is not the bridges along the river, but the exit of the river.
That's
to the sea.
the question. Really, very important question. If you look at all the rivers, I mean, in the eastern or western part of the Black Sea, you will see most of them are blocked by sedimentation. And also some other things which sometimes you can see some road there.
Yes.
Road from this side to other side to block the riverbed and to use the transportation. Can you imagine that one? All these things. Who's responsible for this one? And the second thing, if I ask you, Mr. Kubilay, Dr. Kubilay, will you please design for me for the protective measures of the Bozkurt floods in the upper part of the river basin, using 1,000 years time. I mean the return period. What do you think to prevent this flood in the upstream part of the river basin? What do you think about that?
To prevent, it's almost impossible. To protect or mitigate, yes, we can talk of something, but to prevent is, I don't know, I'm not quite sure about this. Perhaps there is some way, but...
And the next question?
It is not the question. I just want to respond to this
Yes.
question. Maybe I can be kind of explanatory. You are right, because of we are always thinking about the basin-wide measures. Always we need to think about the upper basin uses. If in general in Black Sea region there are some changes into forest to agriculture, so one thing might be one reason might be this, because in that case you might have more debris while the rainfall comes. So it will reduce the capacity of the river channel. The second thing might be the slope. Slope is in Black Sea region is very steep. That's why we need to have some traps for those kind of debris. If we have some traps for the, as you said, like some of the debris, like not only some parts of the forest, and also the other things like rocks, small sediments or something like that. So we need to find out the ways how we can trap that on the upper basin in time. And also some plantation activities might be possible. But if we change in a large amount of land uses from forest to agriculture, that may happen all the time.
Yes.
So that's one explanation in my side, in my case. So I observe those things. Thank you.
Thank you.
Yes.
And the next question, yes.
I have a question about the velocity you measured in the river. I'm a little suspected about that because even the river slope is steep. The receiving to the velocity of 7 is rare. And
It's too high. Right?
So high.
Yes,
because,
exactly.
Near that velocity, we will enter into cavitation.
Mhm.
And because of it, I think also the water flowing in the river is not pure water. And because of it, we have to, for example, we can say like hyper concentrated fluid. And because of it, its density will be very high and the velocity will reduce about 4 or 5 meters per second. And as I see in the video, I think velocity was about 4 meters per second because I worked a lot in hydraulic laboratory and have a sense about the velocity. I want to say on this.
Yes, thank you for this question because the reviewer of the paper also asked us this question as well. How did you calculate this too much value, 7 meters per second? And our response was very simple. We are not really insisting on 7 meters, but it's just a very simple way of calculating. We opened the video, pointed out a sediment, watched and measured the time, and more or less measured the distance from Google Earth, and we divided. It's not a big science. So there may be some mistakes, of course, because we also checked the typical values. 7 meters is very rare. 7 meters per second is very rare.
But even the 5 meters density is very high. Therefore, it is very distant. Therefore, it's very distant.
And also, as discussed, because in the pool we have depth, the solution will be in upstream of the river and will be related to control of sediment and watershed management and, for example, land cover or control the geology of the basin, how we could control the sediment yield in the
Look, these are all very important issues and questions. After visiting Bozkurt, I have the sense of this. If you are building a settlement to a place, to a location like Bozkurt, which is prone to flood events, then you have to make everything perfect afterwards. Not a single wrong issue is acceptable. For instance, you have to design your river channel perfectly. You have to care for your river channel perfectly. You have to design your bridges perfectly. You should not do some stupid pedestrian bridges there. Even with the pedestrian bridge, that flood will occur. I mean, I'm not saying that, but every step should be perfect. For instance, Florida, there are catastrophic floods and typhoons. What they do is very simple. They don't make any foundations to their high-rise, even low-rise buildings. They make no floors below the ground level. And the first 6th floor in every high-rise building is car park. First, second, and 6th floor is a car park. Why? Because there are lots of typhoons and floods there. It's very simple. They don't settle there. So if you let people go and settle there, then you can say that if you build your structure above the flood level, then you have to use piles below the foundations, let's say. Even if you choose to embed your structure, then you are not going to use the bottom floor and the first floor. No settlement there. Okay? Use the second and third floor. These are some precautions, but if you don't use any judgment or if you don't decide to do things and then you let people live as they are, then you have such incidents. So what I'm saying is, if you are settling on a risky place, then the other things that coming afterwards, every decision has to be perfect. Even one wrong can make everything garbage.
If everything will be perfect, I have a very, very important question. Can we decide that one? We calculated it is returning time is 1,000 years. Okay? Can we decide that one? We will use this discharge to protect some area which I showed in my presentation. Several cracks opening to a Black Sea. Can we use these codes, this discharge figures to protect these areas for flood routing, flood protection, flood control in structural measures? Yes, technically we have to use, but will we decide that afterwards? We have to say that 100 years return period discharge should be or must be used for the design value. Can we say that one? In this case, what will happen? This is a technical measure aspect for this. If we accept this one, some expert will say to us, okay, Mr. Yıldız, you are so right. Because you see, our calculation showing that the next one, the other one, also under these risks. So we will change our mind as well as our design criteria for flood protection, prevention, sorry. Or second alternative, we will accept some risks. Okay? Most of the time. I used to be a director of the research center of the DSI. Also, I used to be a hydraulic laboratory chief in this center for a long, long time. Therefore, we faced a lot of things during my working time in DSI. Or we will accept some risks. And in this, under this risk evaluation, risk reduction, we will protect some other part of the area which is prone to flooding.
Yes.
We have to share the risk from prevention and protection. To me, otherwise, it is impossible to find financial solution to that.
Yes.
Because at least, according to my knowledge, at least more than 200 very sharp and the very strong cracks which is opening to the Black Sea is directing us prevent and protect this area just nearby the sea settlement area. If we decided to protect all of them, we need money. Nobody can give this money to us. So we have to share the risks and we have to find the applicable knowledge. Applicable knowledge. Otherwise, it is not easy to struggle.
Yes.
These things.
I agree that we have to reduce the risk to a manageable level. To a manageable level. So we cannot say 10,000 people to leave Bozkurt. But a simple decision could be by the municipality to make the growth of the city from east side to the west side. This is something very easy that they can decide. If possible, I don't know. Because making new buildings on the east side is a suicide. It's we know. We have witnessed. But I don't know if the city planning and the other things are also important. If possible.
It is not possible.
Yeah, okay.
Yes, maybe we can continue in the lunch. And now it's the lunch time. After the lunch, we will continue with Dr. Balaban and then on-site presentations. Thank you. Okay, thank you so much. And now we're afternoon session. Before our expert, I want to give some information about on-site presentation because we have some online and on-site presentations. Each participant has only 10 minutes for the presentation. All the QA sessions after all presentations at the end of the on-site and online presentations. And thank you so much for all the participants from now. And I want to introduce our last expert, Associated Professor Dr. Meltem Şenol Balaban. She was graduated from the City and Regional Planning Department at Middle East Technical University in 1998 with a bachelor degree in city planning and subsequently did a Master of Science degree in urban design. Dr. Balaban holds 2 PhD titles. In her city regional planning PhD thesis, she focused on flood disaster management in Turkish cities, targeting the associated risk for society and planning processes. In her second PhD in urban engineering, she developed a GIS-based model for spatial distribution of potential urban spaces used as evacuation and temporary shelter city sites and plotted this concept in a case study of a district in Istanbul. Her experience is highly relevant when it comes to applying disaster risk prevention concepts in a very practical way on the municipal level. And now, floor is yours, Dr. Balaban.
Okay. Hello, everyone. So I need to, I guess, just open my presentation. Then I have, I think, 30 minutes. Hello, everyone. Can you hear me well? I hope you can. So I will talk about today flood risk management and urban planning, actually, as a topic. But of course, I will point it out mainly possible causes of flood disasters in Turkey. So just thank you very much for the introduction, but maybe I can just mention 2 things here. During my Japanese experience, I experienced the Tohoku earthquake when I was there in 2011. 1 year I spent there after the Tohoku earthquake. I was in Tokyo. So during my 3 years PhD study, I also observed, it was a good opportunity for me to observe Japanese experience regarding earthquakes, evacuation activities, as well as flooding, because you know that there are a lot of typhoons there. So maybe time to time I can share some information from Japan. And also I would like to introduce our center from at METU. We have a Center of Disaster Management Center, Implementation and Research Center since 2097. So today I would like to talk about some topics, some subtopics regarding the flood risk management. Actually, Professor Dursun Yıldız talked about many common things with my presentation. Thank you very much. Maybe some overlap so that I can skip because of that to save the time. So I will talk about a bit disaster statistics because it is a global issue, the climate change impacts. I will talk about some flood risk management steps considering this cycle regarding this risk management issue, and some examples from the other countries comparing with Turkey. And in 2009, I concluded my PhD on some river cities in Turkey. So I will give some examples, some findings from that research, which maybe you can find some common points from the previous disasters in Bozkurt and other places, so that you can see that we might see those kind of damages in the future too. So we have still similar problems in river and cities. And of course, the main idea is just to give you some essence about integrated flood risk management so that we can discuss what could be done in the case of Turkey. So of course, most of you know, this is a kind of a repetition, but impacts changing, disaster impacts changing and transforming. And maybe this is because of the number of population who are living in urban areas are currently increasing. maybe in 10 years, the time period, it might be 75% world population might live in urban areas. So we can say that highly populated and dense settlements around the world are exposed to multi-hazards, and that are increasing in frequency and intensity. Of course, the numbers are increasing, and we are losing a lot of money on that. I mean, maybe we can save lives comparing to historical times, but still we have some kind of, changing some shares of types of the different types of the disasters, I should say. So that when we compare some of the different types of the disasters, we can see that recently some of the hydrometeorological disasters are increasing in a high percentage in different countries across the globe. So extreme weather conditions, flooding issues, droughts, extreme temperature increases. So they are day by day increasing in time, so that we can expect those things in the future too. So we should say that actually cities might be the both cause of that kind of climate change issues, because we are still spending energy more, and we are also the victims of the results of that climate change impacts and crisis. So as you can see, across the globe, there are a lot of people deaths from the disasters as of 2020. So of course, we should accept that currently in the agenda, international agenda, because most of you might know that Sendai framework also tells that we should need to consider and focus on mainly risk prevention other than only disaster response. As we also experienced in Kahramanmaraş earthquakes, we saw that if you don't invest more on disaster risk prevention and reduce the risks, you may not be successful during the time of the disasters, and you cannot save the lives that kind of damages at the same time. So we should try to reduce as much as we can, so that we can save the lives afterwards. So always we should be proactive other than reactive in that issue. So actually we are together now for the workshop, and actually the results of the workshop is kind of critical and important in my case, in my opinion, I should say, because by the help of some kind of estimation studies and some kind of scenarios, so that you can estimate possible risks, and if you can produce better hazard and risk maps, so that we can take some reactive measures based on that. That's why I find it very critical on that. But of course, it's not the only way. I will come to the point, which is very critical. I will come to that point too, that as you can see in this graphic, I just would like to highlight to you that it's a kind of a triangle, but the large area is highly depending on the data. So we need to have, if you would like to deal with disaster risks, any risks you can think about, flood risk, one of them. So we should have have better data to define the hazard based on the space. So we should try to find better ways to collect special data, and need to create and find out hazard and vulnerability analysis on that data. And then, of course, by the help of some, susceptibilities or some kind of vulnerabilities, we can define the risks based on that. That is also another part. Based on the risk identification, we need to also evaluate to decide where to start, where to prioritize our risks, and then we can plan our time and our sources based on to reduce these risks. But the key and the largest of that area also needs to be considered to solve some problems during implementation phases, which is the most problematic area in the Turkish case as well. So, of course, maybe I can say that the risk can be defined by hazard and the vulnerability. So if you have a better adaptive or mitigation capacity, coping capacity, you can try to find power to reduce that risk as much as you can, so that you can have acceptable level of risks, can deal with after if any event occurs. So there are a lot of examples. Most of you familiar with it in the past, some kind of hurricanes, floods, snowfalls. They are all hydrometeorological disasters we came across. So, of course, most of you, again, know that flooding is a temporary or seasonal thing. Normally, those areas are dry. Sometimes maybe this is a kind of misunderstanding. If it is a dry, so some people think that there will be no flood anymore, maybe. Sometimes they cannot read the geography because it is a long time period. You cannot see that there is any water ongoing. That's why you can think that, okay, there is nothing related with any flood, but there can be dry rivers there. So it's a temporary covering of land by water outside its normal confines, and also temporary inundation of the normal dried lines. So there are main factors. We can talk about meteorological factors, hydrological factors, and of course, human factors that can create. But there are also different types of floods. Most of us know that river flooding, mainly in Turkey, we are also experiencing some flash floods in cities, because we have very few green areas. We have very low capacity infrastructures because of the dense, high population of urban areas. There are also coastal and tidal floods in the coastal areas of Turkey, and urban drainage flooding and groundwater flooding you can also observe. Of course, it's something, how can I say, it's a fact that there is a water cycle going on. On Earth and together with the atmosphere. So we should accept that this is something that if you block any part of this cycle, there can be some problems. So the water with the rain comes to the Earth, then it needs to be infiltrated in a better way, so that it needs to feed. It should feed the groundwater levels, and it will also continue this cycle regularly. In a normal time, it's a fact. But as you can see from some photos on the slide, you see that if there is a very few urbanized population on the floodplain areas, you may not see any damage. But if there are some establishments and high dense population on those flood-prone areas, you can have those problems. That might be the same example in Bozkurt we were talking about. So this is also highly related with the time of the flooding. We observed, we saw the video footage from the Bozkurt. It was only 1 hour period. You see that very high level of floods. So maybe in the past, you may not see that fast run of water ongoing. So it is highly related about the urbanization, infiltration capacity, artificial lands, and so on. Many factors can affect for that. But we need to define hazard and vulnerable to that hazard, what kind of assets might be vulnerable and how much vulnerable. If the flood level we know, and if we build our settlement above that level, that could be better risk reduction, and so that you may feel that damage very less in that part. But if you are maybe 1 meter floor below the water level, it's obvious that you might have that kind of problem and damages. So it is necessary to define. Actually, the same as as I defined how the water cycle needs to be secured, we also need to think about the same system in the process of risk management, flood risk management. So the first thing we should do, we should get as much as data and accurate data from the area. That might be kind of hydrometeorologic data. Of course, there needs to be some data from the space. Some other data needs to be gathered. And also, we need to have some hydrometeorological models and some kind of design discharges. And of course, hydrometeorologists, they can give better example on that. But at least at the end, we might have a kind of a water levels and the extension of the flood area based on the return periods, so that we can understand which area is highest water level and which area might be more vulnerable on that, so that we can decide based on the scenario what to get, what to do before it happens. So we need to avoid the risk. We need to maybe at first we can decide that not to settle that area, and if there is no chance to, if there is no space to settle, then we should take our precautions to water levels and by reducing the levels we can settle. And if we can do that acceptable levels of risks, then we can share those risks afterwards by having early warning system and insurance systems as well. So the best thing we should do, we need to know the whole river basin as a whole, as a system, and we need to have a better combination of structural and non-structural processes. So one thing is, as I said, representing risk, calculating and representing risk are necessary. So we should find the ways how to do. Second thing, these are some of the examples to create such kind of maps. And you can have risk zones based on if you have a flood, you may lose that much of money per meters square, so that you can either move your place or you can try to reconstruct your place to reduce the risk. That's an option. So it is depending on, you can decide as a decision maker or the property owner, you can decide. This is from example from the Germany. So adaptation and risk reduction measures can be a lot of, but in the past, two main areas, structural and non-structural, and currently we have gray infrastructure, which is highly related with structural measures. The other two is green infrastructure, which is like nature-based solutions, we can say, and soft measures like land use decisions. We need to also policy changes in that case. Some programs, information, some financial incentives can be counted as soft measure as well. So there are some examples from other areas. This is something that you are doing some structures to protect your property from any flood water. This is the traditional way. Still, we are, of course, depending on in cities, those structures. Otherwise, we cannot live in those cities. So there are also, for instance, in Japan, underground temple, they called. They have a very huge amount of area underground of Tokyo. When it's, typhoon comes, you cannot see any water going around. So it absorbs because they accept that it will come. So they need to spend that much money. Maybe 6 months it's empty, but maybe 1 month it is very useful. Green infrastructure is the second thing we should consider. These are some kind of, we talked about in the previous, speeches that we discussed. So on the upper basin area, we can have such retention on detention ponds, for example. So it's a kind of another way of having some, permeable spaces around. Some roof gardens can be another system. Some kind of course, urban planning is the key. So we should decide, and we should be always think about alternatively. So maybe there can be some, river course and some, protection areas, but it doesn't mean that is the, static way of having that rainwater all the time. Climate is changing. So we should have a B plan So maybe we should have some recreational areas around the river channels so that it can also absorb the excessive water if there is some problems or some kind of high runoff season. So that we should decide where to locate residential areas, where to locate some recreational areas. So safe grounds should always be for the residential area. For instance, for also some of the public uses for hospitals or schools. There are some examples. So I will give some examples: flood maps, hazard maps, and some risk maps from the European countries, as you can see. FEMA, I recently visited FEMA website at US. You can easily visit the website and you can have a look. If your property is somewhere in this flood regions, you can either decide not to buy, or you can decide I need to reconstruct my property based on the base flood elevation, which is 100-year flood, so that you can pay less premiums for the insurance. But it is open to anyone. So this is what I would like to see in the future in Turkish case as well. So open source, everyone can easily access and can get some information. These are the other things on the legal side. We don't have floodway, we don't have flood fringe, we don't have something that areas that needs to be owned by the river water, excessive river water. Do we? No. Because in the postcard case, we saw that floodplains at the end covered by the floods. So there is no law that nobody can settle on the floodplain area. We don't have such a enforcement for the settlements. So in Philippines, they are also doing some hazard maps, but not only floods, they can combine with landslides, because floods might cause landslides as well. So they are at the same sheet. You don't need to get that one data from some places, some other institution to get the other, but they need to be together, for instance, in this case, so that you can consider what to do later. These are some examples from the case of Netherlands, so that they are living with water. They know how to live with water, because more or less most of the area is under the water effect. So they have many different experiences, and they have a law enforcement that they need to set aside 10% reserved area for temporary water retention. It is a law, it's a regulation, so everybody needs to occupy. Needs to set aside some area for the water, flood water. And there are some, of course, new techniques and new building techniques, as you can see. When the tidal waters comes, those floating houses or homes can also be occupied with the residents as well. So when the water level high, it's just float by the water, for instance. If there is no land to live, you can also consider such solutions. There are some, of course, housing layouts, because there is enough space, those kind of greeneries, and so some activities also needs for some recreational activities for the people who are living in these cities. So why not? We are not using those areas. For instance, some kind of how should I say water-related activities that we can use it. So there are also another way, like a riverside regeneration. So nobody is currently, in the past, everybody or most of the countries, the policymakers, they are trying to make some reclamation plans for the river channels, like always, concrete channels. They are trying to make them better way and to open it for the development. But now they change the attitude to make them leave the area for the river. So some mixed residential developments, so you can see, and the same as like in the past, in the channel you can see, but if there is enough space, you can just leave the area for the flood water, so that maybe you can do it in the upper upper basin area if there is enough space, if there is no property, so that we can use that area for the river water. So these are some examples and some parks. Normally, as I said, in the definition of the flood, normally it's a dry land. So we can use all those areas for our seasonal activities, some festivals in this example, for instance. When it floods, when high rain comes, so it is stored a lot of flood water in it to protect the city. So if you have such a park, upper basin area, that helps us. The same as here, urban parks as well. Some housing with sustainable drainage is possible. So, of course, we need to always use the floods, historical floods area or flood levels in the public eye. I mean, in other countries, in Germany, for instance, they have a monument. It tells you that level in 19 or 1856 flood was there. So in that park, the monument is somewhere here. Somewhere here. So the level is just flooded, might be flooded. So nobody can say that, okay, I need to build something else on that area, because everyone knows generation by generation this area is flooded once. In Barton, for instance, in 1998, there is a flood level drawn on a building. Yeah, it's still there, but nothing has changed, I guess. So let's see. Integrated water flood risk management is the key. So not only the structural measures, but also we should think about the non-structural measures, green infrastructure and other things we should consider. And there are some concepts that we can see all around the world. So we may consider those things as well. So let's come to the Turkish case and I will wrap it up. So this is, a lot of river channels you can see across Turkey. Of course, there are not only nature-induced disasters, we have also man-made disaster, but floods are having the highest percentage as well, following the earthquakes, so that we can say, as well as forest fire, extreme heat. When you combine all of them, it might exceed also earthquakes as well. Anyway, so these are some other examples. Let me skip some of them. And these are very recent, and normally we may not come across in the past. So there are some also these things in Antalya. So we need to also prepare ourselves. We are not a tropical country. We might not have a hurricane, but there can be possibilities. So be careful about that. So in my PhD thesis, I searched on some 4 different cities in different river basins, major river basins, maybe a bit old, but the mistakes are common. So I will share with you for this. Like this is from Barton. So in this case, also I have a look at all the basin area, river basin, and also the urbanized population, and to see the previous flood extension areas, how city grows, and how what kind of effects can exacerbate the damages after flooding effect. I will come to that point. In Batman city, there was a large flood in 2006. There had been some kind of problems. Like the major thing is there's a stream, a main channel, and there are some tributaries. But in time, tributaries can be, thank you very much, can lose its connection due to some urban usages like roads or some kind of decisions. So it also exacerbates some problems. In Aydın, the same thing we can see. There is a whole road. Under that road, there is a river. But currently, you cannot see the road. In Ankara, Kavaklıdere, Cevizlidere, they are all rivers, but you cannot see the river. The same thing in Antakya. There is no Amik Lake currently. In the past, there was. but it is right. Okay, I'm coming to the last slides. So these are the our attitude. I mean, we don't like the rivers. I mean, in Turkey, we don't like because it smells, and sometimes we dump some, waste in it. So we don't want to see them. Everybody wants to, stay away. So this is the problem mainly. So we should take care about that, the rivers actually. So I'm coming to the major points. It might be the similar things today. So there are some, on the right-hand side is the summary that I can sum up from the 4 cases that low capacities in time due to population increase, but no change in existing infrastructure. In many cities in Turkey, you can see less permeable spaces, low infiltration capacity in urban lands, unauthorized developments on riverbeds, floodplains, and some closed sections of river channels at city centers, like in Ankara. You cannot see the river, but there is a river beneath the city. If there is something happen in that area, it's also problematic for us. Low capacity of river channel due to other uses and activities in riverbeds. So those activities, something like we are dumping some, sewage and river rainwater and some waste as well. In the Bozkurt case, improper design of bridges and narrow concrete channels can be another problem. So we should be aware of how to design, bridges and river reclamation activities with non-nature-based solution. So not easy to change for the future extremes. What I mean by that, like when you have some reclamation projects in a concrete channels, you can give the people that you are safe, totally safe, so that you can settle just beneath the flood wall. It may change in time. Climate is changing. So it is not really easily possible to change the existing location of the buildings based on the changing new conditions. So we should have some grading for having some different land uses. Maybe we should have recreational area, then several meters away we should let them, the people who can settle down. Another and the most major thing is basin-wide land use solutions. So as we all talk about, it's a basin we should always think about, but in a basin there might be several cities, and in one city in the upper basin, if do some changes, then the lower basin might be affected if they have no chance to say that please don't do, otherwise we might have a lot of flood waters in our area. In Syria, there's a dam. There was a rain in the past, so they opened the spillways so that in Antakya, Hatay, sunny day, suddenly there is a flood comes from the river. That's one of the issue, for instance. So we should also be careful about that. These are some examples from the maps we have. It is Taşkın Portalı, flood portal of Water General Directorate, but currently it is not open. So I just give you some comparison that Kastamonu Bozkurt flood is more or less the similar results, so that we know where to flood, but we don't know what to do to prevent or reduce the risk. So the key is integrated river basin risk management. So we should be need to prepare and share with the openly to public, so that everyone knows what to do. And also we need to consider countermeasures for the risk reduction, not only at one place. Is a basin-wide solutions we need. We need one administration for basin-wide maybe, but currently we don't have. And regeneration projects maybe we need it. And for the emergency on early warning, if we have a good early warning, we can save historical areas, some areas so that we cannot, for instance, relocate them. But by the help of early warning, we can save the lives. Thank you very much for the attention. That's all. Sorry, quick presentation. So yeah, I try my best, but.
Thank you so much for this informative presentation and so meaningful examples we saw, and also all the summaries integrated water basin management. Maybe it's so significant for me. Thank you so much. And have you got any questions? Maybe here, or you can share.
Thank you very much for this very valuable presentation, which is we are agree with you most of the time.
Quite similar with yours.
Okay, thanks. My question is very simple one again. Having a lot of experience, learned lesson. You are a city planner, aren't you? Okay.
Yes.
As a city planner, most of the time cities are planned with the rivers. Generally, there's a river.
Yeah.
Most of the time, you see the river. 1, 2, 3, 4, 5. Okay, as a city planner, after having all this experience and the climate change knowledge, what do you do to plan a city, vulnerable city, and the city which the people would be very safe in this city and will not be affected by the floods? What do you do in this case?
Okay. So thank you for the question. It is quite difficult. You know, we are not designing or planning cities on an empty land. We are living in cities. So we are designing new or deciding development areas based on current conditions. So 2 things we should consider. 1, how we can decide where to develop, which direction, west or east, as you said in the Bozkurt case. It is highly depending on the data at hand. The second thing, how we should change the existing cities to make them more resilient to floods, as you said. So we need to, for instance, if we observe that very frequently some floods in several cities, at one city, we should decide to relocate some settlements, existing settlements, to safer grounds. One option. Maybe very close to river channel. Every year they have a problem of flooding. Every year we need to spend a lot of money to give them, some kind of, damages. We need to pay for it. But it may be more expensive than to relocate to those people to another place. So we should, as a decision maker, if we are in the city council, we should decide, okay, maybe 20 people are living there, deciding to move another place and change this land use of that area into the green area, so that it can be useful for the infiltration and higher level of flood water. Another thing, which is very difficult, but there are some examples, to open some river channels, revitalize. Or in South Korea, they did it. I mean, they spend a lot of money. Now it's a very focal point. Everybody goes there. In the past, it was an autobahn. It's a road. Now they open it as it is, like a river in a natural way. It is meandering, and everybody is now in the middle of the very expensive city. They are using as a focal point. So there are many places. And the third thing is we should invest money to infrastructure, to store the rainwater and separating them from the sewage water. There are more, but just conclude like.
after all this experience, do you think that
That could be possible in
no,
Turkey.
No. Do you think that to settle, to build a city very away from a river, which
No.
is no.
No, we should find ways to live with it. We cannot
That's
be
another
far.
matter. That's
Yeah,
important.
sure.
If you would like to live with water and with river,
Yes.
of course, your way of thinking will be different.
Sure.
And these differences,
Yeah, I mean, there's a, we need to find a middle way so that we cannot very far, but we can use closer uses to rivers as a public use for green areas or sazlıkların İngilizcesi gelmedi aklıma. Water marshes in the upper basin, there can be possibility. So it is something like, also it helps us ecological restoration as well. So we need to just leave the actual plantation to the river at some places, but not so far, of course. Or in Japanese case, for instance, they are highly depending on infrastructure, as I showed you, because many people, and there is no way to a way out. So you should find ways, maybe some structures or to water just lets go through some columns so that you cannot use it as a habitation. There are some ways, but the thing is, how could be possible in the case of Turkey? That's not possible. We should think about.
Thank you, Dr. Balaban, and thanks so much for the question. Now, the turn is yours. We will listen the participants' presentation. The first presentation is from Musin Vanolia, a multi-criteria approach for assessing flood risks on railway lines in Turkey. And thank you so much again, Dr. Balaban. You have 10 minutes.
Hello, everyone. My presentation will be about railway and route infrastructure. Professor Dr. Cemavci and I prepared this presentation for this collaborative analysis flooding event. Actually, for this presentation, I start from the basics, and previous presentations helped me to speak about basics less. The content of presentation will be flood risk resolution, flood risk in construction, and in a specific construction such as railways. And after that, I will speak about the existing acts and investigation and the work about flood risk in railway construction. In the end, I will present my proposal for Turkey, how we could solve in the developing country such as Turkey for infrastructure development. In the first slide, I want to specify the situation that flood risk have. Generally, flood risk is a natural, uncontrollable environmental disaster, not controllable. We have a lot of experience about flood control in the previous years for decades. But when we stay today and see or back, we see even in advanced countries, we have a lot of floods, have damages. And this means it is not controllable. That is the environmental as a category. That is the environmental disaster and related to lack of knowledge of us about floods. And we try to convert it to uncertainty by analyzing, by simulation and so on of the flood nature. For analyzing, we classify the ignorance or uncertainty in two types, objective probability and subjective probability. In objective probability, it is independent, and we do frequency analysis for floods, or we use some tools for finding the external conditional floods. And from that, we find the design floods. And from design floods, we receive to, for example, structural or non-structural methods or flood mapping as non-structural method for control of the floods. But some part of our uncertainty related to subject probability, and it is related to degree of our belief and also our confidence about knowing the things, for example, about climate change or damming. But it is not independent and related to other things. For example, about damming, as you know, Dr. Kublai this morning speak about the structural risk we have for floods. And in dam bricks, that is related to risk of geotechnical, structural, and other risks we have. And it is not related only to the flooding or breaking of them. It's not related to the floods. Also, climate change is something made by the human, and it is related to the decrease of carbon dioxide. And if we decrease the carbon dioxide, we can reduce the extreme floods and its sequence. As an introduction for flood risk, I presented that. About construction, we in construction have a lot of risks in structural, geotechnic, and also hydrologic. In hydrologic, the important part is flood risks. And flood risks can be classified into temporary risks and permanent risks. And I write some aspects of temporary and permanent risk in the construction here. But I want to continue with some example about the flood risk in construction. For first, I give here the river diversion during construction of a dam. We use a risk, for example, 20 years return period for design of diversion system. But if we increase the return period to, for example, 50 or 100 years, we have to consider downstream flooding by the breaking of the coffer dam. And because of it, the risk controlled by different aspects that we have in our environments. And also, as an example, I present here the canalization of urban rivers. You know, urban rivers, land use change and climate can affect the urban rivers and increase the floods of rivers, and because of it, increase the risk, and this is not controllable, actually. And also, I presented the construction of transportation infrastructure from the socio-economic aspects that can affect our environment. Here I presented the flood risk in railway as component of alignment of the river, alignment of the railway and the substructure, bridges and culverts. And we have, when we constructed the bridge railway, bridges and culverts and so on, we have extra backwater and also a scoring of the structure, and this is related to case can make damages. And the construction of railway generate new extra risks in the area related to backwater that can be affected socioeconomic in upstream, and also a scoring of alignment and damage of the railway. The acts we use for risk analysis in railway construction in the Europe is flood directive, and in Türkiye is the act of the flood related to flood risk management, and also the Suçları acts, but they are not enough for working. And because of it, I presented here different works down in the world for solving this issue. For first, I presented work from Italy. They are working something like flood directive, but added some data, simplified data for the area. Other work did in Sweden, and they related flooding depth to land use and also elevation and size of the river. Other work did in China, and they do a procedure of hazard, exposure, and vulnerability for measuring the disaster and risk on railway construction. And also my proposal for Turkey is a simple combination of land use classes, historic of protected area and heritage, and catchment area. Here I use a multi-criteria analysis for finding the extra risk level in the around the railway and area, and by detailed hydrologic and hydraulic analysis after a specification of the zones, I can resolve the extra risk there. Also, I presented here a table of the multi-criteria analysis for that. Our criteria will be population and urban area, economic facilities, protected area and historic monuments, and catchment area size. For case study, I used Yerköy Kayseri high-speed train project. Here you see I presented a bond for the alignment of the railway. And also here I specified the basins to the railway. And after that, by the criteria, I specified from 100 bridges and culverts, about 20 of them as significant and very significant risk that content there. And from that, I, by hydrologic and hydraulic calculation, find how change the environment by these models. And also here, in other case, I use Bandırma, Bursa, Yenişehir, and Osmaneli high-speed railway. Here also we added the climate change here. You see here a graph related to Bursa. Annual maximum daily precipitation increasing trend. And by considering this criteria, I specified there 3 zones. And by hydrologic and hydraulic calculation, I find the extra risk that can be generated by the railway system in the floodplains. And in the end, I presented very fast this part. In conclusion, my aim for presentations this work here was to awareness about the railway increasing and in railway construction increasing and its flood risk, to consider that in the design and construction. For a specific conclusion, I can say my purposed approach can be completed and used as an act or as a procedure for finding extra risk and reduce the damage can be produced in the future in the railway construction and transportation infrastructure. Thank you for your attention. It was, you said you don't have time and I accelerated it.
Thank you so much for the speed. And the second presentation will be online. We will do the QA session after all the presentations, and maybe you can
Thank you.
take your seat and
Okay.
then join to the QA session after. And we will continue to the presentations, online presentation we have. Hayat Han, integrated study for hydrocarbon assessment of Joya Mayer area, Upper Indus Basin, Pakistan, using seismic data and well logs. Are waiting, or maybe we can pass to on-site presentation. Maybe we can wait a little bit. How can we warn? Nasıl uyarabiliriz? Maybe we can pass to another presentation. Hayat is Hayat online? Yes. Maybe we can warn him about unmuting. Okay.
Şu an mikrofonunu ve kamerasını açarsa hazır. O altta duran kişi. Evet. En altta duran.
Streamer one mı? Şuradaki mi? O benim ama.
Yok. Oradan ayarlayamıyorsa buradan.
Ha, oradan görebiliyorsun.
Şu an sadece kamerasını mikrofonunu açsa yeterli olacak. Buradan ses de gelecek.
Şuraya yazmışsınız zaten, evet. Muhammed Anizhan yazmış. Here's a great view. İşte kendi aralarında konuşuyor. Maybe we can pass another presentation and solve this technical problem after that. And the other question, other presentation, sorry, from Selin Güzel, analyzing the impact of land cover and land use decisions on floods with multi-temporal Sentinel-1 SAR and Sentinel-2 data, a case study of Bozkurt, Türkiye. And the floor is yours, yes.
Hi, everyone. Let me open my presentation. If I do this, no, it's gonna, or do I need to do this? Yeah, okay. Hello again, I'm Selin Güzel, and I'm studying at Geodetic and Geographic Information Technologies at Middle East Technical University. And today I'm going to present to you my study analyzing the impact of land cover and land use on floods. So I'll start with a brief introduction. I'll give you some information. Then I'll talk about my methodology and at last expected contribution of my study. So all of you talked about it. Floods are causing a lot of damages, major damages over cities, economies, people, and we are experiencing a lot of them recently. That's why timeline mapping and monitoring is quite important to provide information to organizations in order them to predict and mitigate the effects of floods and prevent some future disasters as well. So monitoring is usually can be done with spaceborne imaging systems. And these are basically practical and very safe to use. However, for flood monitoring, we cannot use, we can use, but it's a bit problematic to use optical imaging systems due to cloud coverage and time of the day. But luckily, we have another technology for that, synthetic aperture radar, also known as SAR. And these systems provide high resolution images to us. And they're not dependent on external energy source like sunlight. But most importantly, for our case, they are capable of imaging under all weather conditions like cloud cover or cloudy weather. So I want you to look at these two pictures there. Image A is taken from an optical imagery system, whereas B was provided by a SAR instrument. And as you can see, only difference is, oh, by the way, these pictures belong to the exact same area on Earth. So only difference is the cloud cover. SAR images, like power of the SAR images or instruments is this. We can get information about the surface even though we have this obstacle between the surface and the satellite itself. So what is the problem? Problem is that, again, as you all know, floods occurring with the highest rate among other meteorological disasters, natural disasters in Turkey, and they affect very large areas, causing many casualties. Coastal areas, Black Sea region especially affected the most due to short-term heavy rains it receives, as well as location of expanding settlements. They are close to the coastlines or riverbeds. And recently, as the population grows in cities a lot more than it used to be, riverbeds are also, unfortunately, also opening to new settlements. And these factors are considered to be or led to the increase in occurrence and severity of flood disasters. So there's definitely need for more analysis about this topic. What is the aim of this study then? It is to present land cover and land use changes over the years of a selected study area. Then to present extent of floods during the same time interval that the land cover and land use change will be, or like land cover and land use changes analysis. And lastly, to present relation of land cover and land use changes to extent as well as the impact of floods. Following questions will also be answered. Which area in a certain category of land use and land cover decreased or increased? Whether the flooded areas increased as well over these areas where we see the change. If so, if that's the case, what change triggered this increase in the flood extent? I'm going to talk about the methods to how am I going to achieve these aims and answer the questions after I talk about the study area first. So the study area is selected as Bozkurt, and it's a district of Kastamonu. This district is located at Black Sea region, and average annual rainfall of this region is more than 1,000 millimeters, whereas Kastamonu itself receives only less than half of this amount. This district was established along the plains of plains of Ezine River, and you saw from the other presentations, river was passing right in the middle of the district. And then not only that, but it was expanded even more on the land of the plain by narrowing the riverbed. Actually, again, you saw a lot of examples of it. So houses and other structures were built over these important areas. And unfortunately, on 2021, this district experienced a major flood disaster, causing a lot of casualties, loss of properties, and it was the most affected area. These reasons I talked about, we also talked about before the break, were considered to be the one of the most important causes for this disaster. So for methodology, first of all tasks will be conducted using Google Earth Engine, a platform. Basically, first of all, land use and land cover change of Bozkurt will be or classified into 9 classes using Sentinel-2 multispectral data. After that, flood inundation maps will be obtained, flood maps, this time using Sentinel-1 data, SAR data. And lastly, overlaying these change maps with flood inundation maps. These results will be analyzed. So I'm going to give just a bit more explanation on the 2 steps. For change detection, region of interest, first of all, it will be important, districts of Bozkurt. Then Sentinel-2 multispectral data will be obtained from Earth Engine catalog. After that, while importing the data, dates will be selected between 2015 and 23. Then we'll have a lot of images, many images, and these needs to be combined into one image per year. And this will be done using median values of the pixels. After that, images will be clipped. Then from the image collection, classification will be conducted using dynamic world classification taxonomy. And this is the taxonomy. Based on these values, classifications will be made automatically. For flood mapping, again, region of interest will be imported. Data will be obtained. For this, dates will be the same between 2015 and 23. Polarization mode is an important fact for SAR images. It's going to be selected, specified as vertical. For many studies, this polarization mode was stated as like giving the best results for representing motor surfaces or identifying motor surfaces better. Dates will be selected, as I said, and then after mosaicing the images for classification, thresholding method will be used. Low values, pixel values will correspond to flooded areas. High values will correspond to non-flooded, and then we'll have inundation maps. So what is the contribution of my work? It is, so many studies have discussed the relationship between occurrence of floods and the causes related to the land use decisions or land cover decisions. But this relationship needs to be analyzed a bit more, and very much the data exploring this relationship will be shown on some accurate maps. So with this study, relationship between erroneous land use changes and land cover changes and decisions and the occurrence of severity of floods will be shown by overlaying these change maps with inundation maps, with therefore allowing the impacts of these decisions to be displayed using SAR and optical data. So that's all I want to talk about. Thank you for your attention. Sorry, I was a bit excited, but thank you.
Thank you so much in mentioned time. Thank you. Presentation and sorry. Okay. And actually, I'm so sorry to show always 3 minutes sign because I should do it to manage the time. And actually, we want to give meaningful minutes for the discussion and interactive study because we have an interactive study about SWOT analysis of collaborative analysis of flood events. And now we can turn the presentations again. And after the presentations, we have a short coffee break and then interactive study will wait for us. And the other presentation from Hasan Bilgehan Makineci, investigation of the 2021 Bozkurt flood disaster, flood from PlanetScope remote sensing data, and the floor is yours. Thank you.
Thank you very much. Welcome. I lost the mouse and start mine. First, I'm not ready to speak fluently in English, so apologize. I will read. And where's the mouse? Dear all, thanks for coming here. My name is Hasan Bilgehan Makineci. I am from Konya Technical University. I am working geometric department as an photogrammetry and remote sensing researcher. Here, I am with you to the remote sensing data discussion. I believe, or my experience is about remote sensing data. This is for NDWI index and PlanetScope remote sensing data discussion. I present you to high resolution PlanetScope or mid resolution PlanetScope data and NDWI index. Okay. This is my representation plan. I want to be quick. So the purpose of the research is to indicate that significant performance difference between medium spatial resolution multispectral data and low resolution data in natural disasters such as floods. And the study objective is to create nearly the perfect flood area extraction with relatively higher spatial resolution than Landsat or Sentinel data, as you know, very famous data sources. I use Planescope multispectral satellite data with 4 bands, RGB and near infrared in the study for remote sensing, which data are acquired daily and with a spatial resolution of 3 meters. The ability to acquire daily temporal resolution is at least as important as the ability to acquire data at medium spatial resolution. So I prefer the daily data with Planescope data. In the study, only data from 4 data I used, 3 August, 6 August, 13 August, and 16 August 2021, sorry. I talk about only Sentinel-2 little. This is low spatial resolution data. With resampling mode, you can use Sentinel-2 data approximately 10 meter resolution and 5-day temporal resolution, Sentinel-2. This 5-day temporal resolution restricts some operations that require daily data. In addition, as with every remote sensing data, optical satellite data also has its own disadvantages. For example, clouds, inability to acquire data at night, etc., or undesirable shining. Normalized difference water index, NDWI, stands out as the most frequent used methods for extracting wetlands in the literature. The combination of green and near infrared bands can produce it. The results are considered reliable and robust. Depending on the discrimination power of the dataset that used, the findings obtained with NDWI index will be more accurate. Furthermore, temporal resolution is essential for NDWI because the detection of wetland is generally not done just to specify the area. It is mostly used to determine temporal changes in wetlands or quick changes in the wetlands, such as flood events. As you can see, the formula of NDWI. There are 2 formula, but we mostly use that one for temporal analysis. I prefer 2 area for the getting outcomes. I used for first RGB image. Among the RGB standard RGB images, 3 August, 6 August, 13 August, and 16 August respectively are represented in the figures. Flooded areas can be seen on 13 August figure when the flood disaster was most effective for satellite data. When its affected are still visible in 16 August, also you can see. The false color, again, coastland and around flood moving in urban areas can be seen more clearly, false color images. By the way, I prefer 2 area, I said. First, coastline, and second, center of district. Center of district shows that before my representation, there are too many good samples at the center of district, but I guess coastal line is better sample for NDWI index. The center of district, because there are too foggy or dusty images in satellite images, I mean. And you can see in false color images, flooded district center easier, I guess, in here, 13th of August. So NDWI, in addition to these RGB or false color images, I analyzed flooded areas with extraction of water within NDWI index samples wetlands can be noticed on 13 August more emphasized when flood disaster was most effective. I mean most effective. This is not the most effective day of the flood. We can monitor with satellite images. Most effective day is 13th of August. So these are some discussions for me, for all. First, free access low spatial resolution datasets such as Landsat or Sentinel satellites are challenging to monitor or compared to the medium resolution PlanetScope optical satellite data as shown in the figure. Which one? I guess right one, Sentinel-2 image, and left one, the PlanetScope image. This is 3 meter spatial resolution and 10 meter resampled resolution. So I select the day for these images recently, like 25 September of 2023. And I emphasize that city here already. After flood events, after flood events, there are nothing to change for living here, for people living here. So daily temporal resolution is required, like that disasters, flood disasters. Very high spatial resolution image, like such as Maxar. You use Google Earth images from Maxar satellite images. Those are very expensive and unaffordable for researchers repeatedly. Second, the resolution of the produced outcomes such as NDWI index increases or decreases because of the spatial resolution. Frequently used index such as NDVI, EVI, or NDWI make better results with higher resolution, as you can see. Lastly, but most important, I guess, as you can see in the figure, the destructive effect of the stream with high pressure comes from 4 different rivers at a single point towards the area shown in the second figure. This causes an increased risk of death and more destruction. Bozkurt district is another important example of many wrong urbanization in the Black Sea region, I guess. Thus, in particular, multiple river regimes move towards Bozkurt city center by being pushed by the sloping and land from high points. In order to prevent the recurrence of significant flood disasters like those experienced in 2021, it is necessary to move residential areas or discuss alternative solutions, as we can do. I believe it will be safer if the areas of approximately 1 kilometer square covered by white area and the same size surrounded by green can be moved to the yellow one and blue one. It will be a mini solution of mine. I am, as I said, I am a geometric engineering, so I am not a planner. It will be I believe that the least large buildings and public buildings should be moved to safer place. Thanks for your listening. Thank you.
Thank you. Okay, one participant, Hayat Khan, actually we couldn't reach him very clearly because of the internet connection, but he will send us the presentation offline and we can share with you actually in the environment. And the other presentation from Sezgin Abukan, analysis of their district in terms of flood and overflow susceptibility using geographic information systems and remote sensing methods. And the floor is yours.
Hi everyone, I'm Sezgin Abukan. In Harvard University PhD student. Analysis of the Derik district in terms of flood and overflow susceptibility using geographic information system, GIS and remote sensing methods. In study area, Derik district is located in the western part of Derik, the Dicle division, in the southern east Anatolia region, northern in Diyarbakır, in the west Şanlıurfa province are located. Hydrological, the district is located in the Fırat subbasin. The most important rivers of the districts are Çırçıp, Akıncılar, and Dikmen streams. The aim of the study, floods and overflow are low-frequency events that affect human life, physical infrastructure, and socio-economic structure. They have direct and indirect impacts in the regions where they occur. Floods and overflows, in addition to being the reason for the loss of life and property, cause a wide range of negative consequences, such as dispersion of article areas, dispersion of transpiration, and dispersion of education and training activities. In terms of preventing possible damages of floods and overflow and responding to these disasters, it is extremely important to determine the potential areas where floods and overflow might occur and to determine the susceptibility of these areas in the term of floods and overflows. In this study, it was aimed to determine susceptibility of the Derik district in terms of flooding and overflow by using remote sensing and geographic information system techniques. In general method, a flood susceptibility map was created to analyze flood and overflow susceptibility of the study area. In the creation, this map stream them data was processed in ARTIS 10.7 software. Parameters such as slope, aspect, elevation, normalized difference, vegetation index, and soil properties were taken as the basis for determining the susceptibility of the area flooding and overflow. These parameters were mapped with GIS. The layers obtained were divided into susceptibilities, and weight values were assigned according to their effect on flooding. The weighted layers were summed up, and flood susceptibility map was created by using weighted overlay method, multi-criteria layer analysis. Each parameter determined was weighted within itself, and a susceptibility assessment was created separately for each parameter. Each sub-element has been weighted again by assigning values ranging from 1 and 5 within itself. 1 refers to very few, 2 few, 3 medium, 4 high, 5 very high. In weighted values of the sub-elements of the parameters used in the flood susceptibility map. Lithology, slope, aspect, vegetation, land use, soil, properties, the streams. Flood susceptibility maps were created by using values between 5 5% and 25% the maps of age classified criteria. The maps were overlapped and susceptibility maps for and overflow were obtained. Weight values parameter used in flood susceptibility map and the spatial dispersion and percentile ratio of the susceptibility classes as classes of floods. Percentage dispersion of the proportion of susceptibility areas in the field and very little susceptibility 16% area. Study area in maps and lithology map, slope map, aspect map, vegetation, land use, soil maps, and proximity to stream maps. Generally, area in maps. There have not been any and overflow event recorded in the district center of Derik in the size of disaster so far. However, the recent growth of the district, the valley flood in the flowing period, it is expected that if the necessary measures are not taken, the floods and overflow will reach the size of a disaster. Oh, okay. In particular, the flood in Kingdom experienced Derrick Hicks School, which was established on the valley floor on April 6, 2013 can be given an example. After the flood in the 2000, there were no caution in the Derrick Hicks School, which was established on the valley floor. Flowing processes, the flood disaster at Derrick Hicks School. There is also expert residents are outside the city center, explicitly those established at valley floor in the rural residence area of flooding and overflowing, as a result of the flood experience in the village of contact to the village of Boyaklı located in the Dikmen Basin on the March. While there was no loss of life in the hamlet, article areas and many residence areas were damaged. In 1-2 photo damaged article areas, 3-4 photo damaged residence area. In the scalability analysis conduct, it was determined that 5.8% of Derrick district is very scalability to floods and overflow. 62.2% is less scalability. 39% is scalability. 1% is very scalability area. Derrick district center, while city areas in this growth is spreading towards the standard bed explicit scalability map of city area. Blah, blah. Looking at the temporal change in the development of Derrick district, it has been that district center has developed towards flood and overflow susceptibility areas in the last 70 years, and the districts have gone towards the stream beds. The growth of the district center, this direction will cause serious damage to possible floods and overflows in the future. Results this study, which conducted to determine the flood susceptibility areas of the Derik district, revealed the highly susceptibility and less susceptibility areas using creating methods. This is an important study for taking precautions before any flood and flood that might occur. With this study, anthropogenic effects and geomorphological condition of floods and overflow occurring in the Derik district area are affected in the first degree. Especially in the Chirchip Basin, it is necessary to allow statements taking into account the flood plain temporary stamps located in the southeast of Derik district and the Derik district center. Thank you for listening.
Frankly, thank you for your presentation. And the last presentation from Beste Tavus, development of the fusion methodology for flood mapping using SAR and optical satellite data. And now I'm giving the floor to you. Yes.
Hello, everyone. Thank you for your participating today. I am Beste Tavus, and I am a research assistant at Hacettepe University Geomatic Engineering Department. Today, I will shortly present our research titled by development of a fusion methodology for flood mapping using SAR and optical satellite data. I would like to start by the explain motivation under this research. As mentioned before in many times, flood events is one of the most devastating and costly natural hazards, and it has severe socioeconomic and environmental results, specifically croplands such as destroying farmland, reducing crop yields, or indirectly loss of energy. So flood mapping is becoming increasingly important, specifically such areas, these areas with fertile croplands lands under the flood risk. In this research, we mainly investigate the potential of Sentinel-1 SAR and Sentinel-2 optical data for flood extent mapping. Specifically, we purposed to detect two flood-related class. These are flooded and flooded vegetation or inundated vegetation. For this purpose, we choose the Sardoba dam break or dam failure case. This case was caused by the dam failure in May 2020. And this case is very suitable for the analysis in terms of data availability and topographical data. And the study area mainly covers the cropland. Here you can show the data set used for the Sardoba case. For this case, we used pre- and post-event Sentinel-1 SAR and Sentinel-2 optical data with 4 and 3 days after the flood. And also, we used for validation process Planet scope data as external validation data. And methodology in the study can be grouped in 3 main stages, as shown in the slide. Pre-processing feature and feature extraction, and second feature selection, and finally random forest modeling, mapping, and validation. The first stage is the data pre-processing and feature extraction. Here, we firstly, some basic pre-processing steps were applied to both SAR and optical data. After that, to produce the additional data sets, we used some spectral indices and some texture measurements, GLCM texture measurements. In the second stage, for reducing the feature dimensionality, the principal component analysis was separately applied both optical and radar texture features. At the end of this stage, 12 principal components were obtained, and we used these components as additional data to original SAR and optical data. In the last stage, we can stack the with different bands to data. Stack 1 and stack 2 data sets with and without GLCM principal components, and then we classified with random forest methods with same terrain and same parameters. In the figure, you can show the classification results for 7 classes. This class: flooded vegetation, flooded area, permanent water within the dam, bare land, urban area, and 2 types of vegetation, vegetation 1 and 2. Stack 1 and stack 3 show differences specifically in flooded vegetation classes based on the visual investigation. Also, urban and flood classes were affected by the use of texture features, and no significant change between the permanent water and vegetation classes based on the visual investigation. This table shows the confusion matrix. This matrix produced by using the Planet scope data. According to the tables, the use of texture features increased the kappa values from 0.6 to 0.83. And generally, in the present study, the contribution of GLCM principal components for detecting specifically in unweighted vegetation and flooded classes were evaluated on learning sets obtained from SAR and optical data. The results show the use of GLCM components greatly contribute to increase the overall classification accuracy based on external data, this data Planet scope. Thus, the use of textural features is highly recommending both these 2 classes. Also, the use of the textural data has led to misclassification or mixing urban pixels. Further strategies can be integrated to reduce these effects. And thank you.
So fast presentation, and thank you so much. And actually, it was not lost. I am now introducing the final one from Elif Yavuz, performance assessment of REC TM5 in simulating high-intensity precipitation, a case study of the Kastamonu, Türkiye. The floor is yours.
I didn't load my presentation sorry about it. Okay. Maybe I can use this one. Yeah. Sorry. It's okay, right? The camera, is it working? Yeah, okay. Okay, first of all, I want to thank you all for this great workshop. It's really nice to see you all in here. And first of all, let me introduce myself. I'm Elif Yavuz. I'm working as a research assistant at Yıldız Technical University Environmental Engineering Department. And I'm a PhD student, and it is my last semester. And this is my study. It's about the performance assessment of REC-CM5 in simulating high-intensity precipitation, and it's a case study of the Kastamonu, Türkiye. I will start with a brief introduction, then I will describe you the REC-CM model, then I will continue with my results of the study, and then I will conclude my study. Here is the introduction part. The figure on the left-hand side, you can see the percentile of natural hazards subgroups in Turkey. And according to the Turkey disaster database, you can see the red one, the red color, it shows the meteorological hazards. And this is the most frequent hazards in Turkey with 31.8%. And the hydrological hazards are the third most frequent hazards in Turkey. And if you want to look at the figure on the right-hand side, you can see the overview of natural hazards in Turkey. And you can see the flood hazards accounts for 8.3%, and between 1960 and 2014, 1,073 flood hazards were recorded between these periods. I'm sure you know that these things, the magnitude of flood occurrences is impacted by both natural factors such as climate, such as topography and geological composition, and it's also impacted by human-induced factors like urbanization and insufficient urban infrastructure. And here you can see the Turkey map, the country map. Due to its topography and proximity to the coastal zone, and due to its synoptic weather patterns, the northern part of Turkey, the Black Sea Basin, is more susceptible to the flood events. And the most recent significant flood event in the Black Sea Basin is occurred in 7 and 14 August 2021. And you can see some photos from that days. And as a consequence of the precipitation event, the Ezine stream experienced a surge in the water levels. And according to the AFAD, the flood event led to the casualty of 82 lives and a total of 2,028 injuries, and the evacuation of more than 1,000 individuals from their residences. And here, what is this model? What is it used for? It's a regional climate model. You can say REC-CM. V5 is the version of this model. I used the 5th version. And the figure on the left-hand side, you can see my model domain. And it consists of 3 nested domains. The outer domain uses a 30-kilometer resolution, and the inner domains uses 10 and 3.3 kilometer resolutions respectively. Each domain has 50 points north and south direction, and 100 points in the east and west directions. And I used 18 vertical sigma pressure levels and 5 hectopascal at the top level is the maximum pressure. And I ran the model for 12 days between 1st of August and 12th of August. And the first 9 days used as a spin-up time. I excluded them. And the table shows the physical parameterization of my Rexium model simulation. You can see some parameters. In your simulations, you can use different physical parameterizations, and it depends on your domain, it depends on the simulation type. It's so variable. But in the simulation, I used the Hosslag PBL scheme. What is PBL? It's a planetary boundary layer or atmospheric boundary layer, we can say. For the moisture, I used the SubX moisture scheme. For the radiation, I use RRTM. For land surface model, I use the CLM 4.5. It means the community land model, we can say. For the ocean flags, I use Lang et al. Scheme. And I also tested different cumulus convection schemes because they are so important for the precipitation simulations. And there are 4 schemes in this model you can use for your domains, and you can test all schemes. And in this simulation, I use the GRASS scheme, the Emmanuel scheme, the Tietke scheme, and also the Kain-Friis scheme, the 4 schemes. Okay, what is this cumulus convection schemes? What does they mean? As I said before, the selection of the cumulus parameterization schemes in the model holds a significant importance because the majority of the precipitation is derived from convective clouds. The GRASS scheme uses a single cloud scheme with updraft and downdraft fluxes, and there is no direct mixing between cloudy weather and the ambient air, except at the bottom and the top of the circulation. And the Emmanuel scheme assumes that the mixing in the clouds is highly episodic and non-homogeneous. And the KF scheme is based on the same fundamental closure assumption as Friis-Chappell scheme, and the convective effects are assumed to remove convective available potential energy in grid element within an advective time period. And in the last scheme, the Tietke scheme, convection is triggered if the process temperature exceeds the environment temperature by a fixed temperature threshold of 0.5 Kelvin. Really? Okay, these are my results. You can see the observed and modeled hourly area average total precipitation results during these periods. You can see different cumulus convection schemes. The orange color shows you the model results, and the blue color shows you the GPM IMERG final products. It's NASA's global precipitation measurement results, and I validate my model simulation result using this kind of data. And it uses spatial resolution of 0.1 degrees. As you can see, there are significant disparities among these precipitation simulations, and the findings demonstrate that the selection of cumulus convection scheme has a great effect on precipitation. And there's a common underestimate of precipitation using Tietke scheme. It's upper on the right side. And in general, the other schemes yielded higher precipitation levels compared to GPM products. And I also tested a mixed scheme that uses Grail scheme over land and MNO scheme over ocean. And the mixed scheme could represent the precipitation variations well for this region. It's the best simulation for this region, for this area, for this Bozkurt district. And here you can see the REXIAM-5 daily accumulated precipitation maps for 10 and 12 August 2021. The figure on the left shows you the daily mean precipitation for 10th of August, and the precipitation measured, the high value is 35 millimeters, and the other day it reached 48 millimeters. And during these days, the high pressure system shifted its position towards to the northwestern and northeastern regions of the Black Sea. And the temperature disparity between sea surface temperature, SST, and the atmospheric pressure level at 850 hectopascal exhibited leading a pronounced converge of moisture at lower levels. And it continued for 3 days in the Black Sea basin. And if you look at the hourly simulation results, you can see a cyclonic air parcel movement for these 3 days. And this is the conclusion part. In the study, I use a REXIAM model and conduct numerical experiments with using several cumulus convection schemes with the aim of investigating the influence physical parameterization on the modeling of precipitation changes in Kastamonu, Türkiye. And the results indicate that the model was capable of detecting the rainfall trends based on hourly data. Using the grass scheme over land and the Emmanuel scheme over ocean produced more accurate precipitation results within the research region Bozkurt. And feature work. Feature work will be the coupling of this model, REXIAM model outputs, with a hydrodynamic flow model DAF3D. With this, we can accurately simulate the sea level height and the bed characteristics during this kind of flood events. And by incorporating climate and hydrodynamic models into the study of heavy rainfall events, decision makers can gain valuable insights into the patterns and potential impacts of such kind of events, and enabling them to make informed decisions about the flood detection strategies and emergency responses. That's the last thing. You can use this model for long-term simulations, and you can use the climate indices for the representation of short and extreme rainfall events that could cause flash floods or shallow or rapid landslides. And I put some climate indices I use for my studies. For example, you can use annual count of days when precipitation was greater than 1 millimeter, 3 millimeter, 10 millimeter, 20, 50 millimeter, and you can use all these indices. And thank you.
Okay, maybe we can wait for Feza Bozar. Okay. Yeah, thank you for your presentation. And in the online presentation, there's no feedback. Okay. Thank you again. As moderator, I learned so much. And first of all, we listened the experts' perspective in the first session. And in the second session, we listened the participants' perspective about collaborative analysis of flood events. And now, actually, we will integrate ourselves to the interactive study. Together, we will make some groups and discuss about SWOT analysis of the collaboration and collaborative analysis of the flood events. And maybe we can integrate together question and answer session and coffee break and this interactive study together. You can go and take your coffee and discuss with your meeting partner group, and maybe you can use the Q&A session together, discuss your lectures and maybe presentations. Okay, we can begin to the SWOT analysis. Okay, maybe. Actually, you can choose your side, and maybe you can see the WhatsApp group, the Google Docs document, and in the Google Docs document there are some groups, and yes, as strength, weakness, opportunity, and threats, all collaborating analysis of flood events, and you can discuss your perspective about, for example, strength, weakness, opportunity, and threats with your group member, and you can use every part of the conference room, and meet your group members and begin to your discussion and maybe Q&A session with the presentations, and you can go to coffee break and just like the free time. And thank you. 4:15, yes, 4:15 is okay. We can collect everything and start the closing session. Can you listen me? One more thing to note, that all of the experts can share the desks, can share the groups, and collaborate together. Maybe give some solutions to the groups. Thank you. Okay, and we are here again. And actually, I will explain in detail about the SWOT analysis and interactive study now. First of all, I want to ask, where is the S team? S. Where is the S team? Hi. Good. W team? Where? Maybe you can meet together for the discussion, and then I will explain. First of all, I will collect all the teams. And O team. Where's O team? O team. Where's O team? You can meet and find some place to be together. And T team. T team, yeah. Oh, so beautiful. You're together. T team and okay. Sorry? Yeah. Can you listen me? All of the teams and all of the experts, can you listen me for the last moderation? And actually now we are actually collaborating together. Actually, we are doing the fundamental things of this workshop. What is the fundamental? Collaborative analysis. Imagine that you are in a member of a project and you are now together. And if you want to study about flood events, just like our experts, they are from different disciplines: engineering, natural science, political science, and etc. Think about that. What is the strengths of the collaborative analysis about the flood events? For example, multidisciplinary approach can be strength of the collaborative analysis, being together. What is the weakness? Conflict of interest, maybe, about the project members. In the project members, you can think, and all of the experts can help you about thinking. And you can see now the Google Docs document, and in the following of the document, you can see here the outputs, S-team outputs. You can write the strength of the collaborative analysis. Think about the project membership and write together as an output. And the other output is W team's output. Only one page is enough to write your outputs, and think about it, discuss together, and think all the lectures from morning to now, because you can think all of the lectures here from different disciplines, and you can think your presentations again. And think about all of the flood event studies, and then discuss together, and you can make your outputs. Have you got any questions about it?
So we're not doing the satellite SWOTs, but using satellites for flood event SWOTs. It's just
Yeah. Everything you can think, and all the experts can select a desk, select a group, and think with them. And maybe you can change the desks, and you can continue to another team, and we can make progress together until 4:30. Okay. Yes, we are now starting. Yes, please continue in English because this workshop is English.
Güçlü yanlar ve zayıf yanlar.
Ben yazayım hocam hemen.
Ben de yazarım.
Tamam.
Yazayım zaman hocam 5'er dakika yazarım. Tamam.
I want to pay attention. Please, during the discussion, don't forget to write your outputs to the Google Docs. Thank you. I need your attention, all the groups. Now the interactive study session is closed because it's 4:30. And yes, for the closing session. And thank you so much, actually, for all contribution to the interactive study. We're waiting for the groups. Where is the S-team output? We're waiting for the outputs now. Tamam. All the groups, Group S, W, O, T, we close the interactive study session. Now we thank you all, and maybe we can see your outputs rapidly. And now we studied together about the SWOT analysis or collaborative analysis for understanding flood events. And now maybe I can read fastly the outputs of the teams. And S team. Where is the S team and outputs I can see? I can see the outputs here. Maybe you can integrate fast. Okay, I'm waiting. İhsan Can, Duran, Gökhan Kızılırmak, Elif Yavuz, Bilal Utancık, Halil Burak Akdeniz. Yes. Thank you so much for your output. Yeah, here. So long outputs. And actually, we asked to you about the SWOT analysis of collaborative analysis of flooding events, and the S-team outputs are forming a team with different backgrounds, adding perspectives. People from NGOs and other disciplines, academia can collaborate together. Decision makers are inclusive and public health oriented. Advanced knowledge management, collaboration makes adaptation. No need for separate organizations. Existing organization bodies enabling better use of manpower. Long-term memory against disasters. These are their perspective, and thank you so much for your output. And W team, that means weakness. Lack of coordination between institutions, social politics problems in land management for floods protection, lack of available data such as satellite images or methodological data, etc., lack of multi-hazard analysis, natural flooding, also risk analysis and precaution for dam floods, lack of the common terminology for discussion, actually so important, and problems of the country now. Thank you. And O team. Oh my God, so long. Multidisciplinary work environment if possible, data output quality improvement, improving the applicability of outputs, accurate team decisions because of different perspectives, radar data sets gave us more usable dam data, information analysis of art structures such as bridges, culverts with interferometric SAR, pre and post hazards monitoring and assessment of critical situations by using all instruments such as UAV, remote sensing methods. Compared to in-situ works, using remote sensing data is more affordable and save time. Opportunity to monitor large sites, possibility to estimate future data sets by integrating different historic data sets, inspiring the future works such as Bozkurt Hazard to all other regions. And thank you so much for this long output. Thank you. And the T team. Basins and water bodies which cross through different countries, therefore political problems may occur, conflict of interest between different disciplines causing miscommunication and not sharing important data and information, technical problems with satellites, the fact that Sentinel satellites dysfunctioning due to explosions of the sun, weather conditions affect data acquisition, cloud cover, sunlight, effects of climate and geographic locations, as well as morphology, population growth, data availability, the fact that there's no much data collected and saved by different organizations, technological developments, short-term heavy rains, lack of data inconsistency, modeled and measured data's inconsistency with reality. Actually, understanding is different, but the total output is great. Thank you so much for the outputs. Actually, now we closed the workshop because actually we have so long time and we discussed everything. We had so many informations, and thank you so much for your participation. For the experts, first of all, Mr. Yıldız, Dr. Keleşoğlu, Dr. Ambaroğlu, Dr. Balaban, and Dr. Kılıç. Thank you so much for the lectures, and dear all, thank you so much for your participation and presentations. Thank you.
I also thank you all for all joining here this I think beautiful workshop for all you, for to you all. And first, when we thought about this organization with Fulya and Doğuşan, also you already listed here the multidisciplinary work. At least this item, I believe we touch especially on this point, and hope we see future publications with the team members of all this workshop all together in the future. Then that will make us happy for sure in the future. Thank you very much, and hope to see you somewhere. Thank you. And lastly, I would like to thank you all our great team from Chamber, Erdem, Celil, and Mert. Really, they did very big effort for us here. And please. Okay, let's make a group picture all together and say bye.